Hello, everybody. I kind of was surprised by my own countdown. I shouldn't have been. My name is Brian Rinaldi. I am not your MC for today. I'm just here to do a quick little welcome to you all because I run CFE.dev, where we're hosting this event and a number of other events. And I just want to let you know a little bit about that, thank our sponsors, and tell you about some upcoming stuff we have going on. So I'm going to start my slideshow, but my slideshow thing was not working well today, so giving me trouble. So I got to do this the difficult way. All right, there we go. All right. So first of all of these events, all the events on CFE.dev are free, and they're free because the sponsors allow me to make them free. So I want to make sure I thank them for doing that because they make it possible for you to come and not have to pay for any of these kinds of things, and for me not to go broke trying to run them. First of all, Netlify. If you haven't heard of Netlify, Netlify is a great place to deploy your sites. I host CFE.dev on Netlify. I've been a fan of theirs for many, many years. It makes deploying really, really easy, including functions, edge functions, all kinds of stuff like that. So check them out. Also, Contentful. If you're looking for a headless CMS, Contentful is really, really easy for both developers and for marketers to use. It's a really great tool for CMS, and you should check them out. Also at contentful.com. So we've got some upcoming events coming soon. We've got a really fun one that I'm looking forward to coming up on November 14th at 1 p.m. Eastern. That's 7 ways to build an API that developers will hate. Lauren Schaefer is going to cover the worst practices in API development so that you can avoid them. So you can find that at cfe.dev, or if you're really quick and you scan that BARC QR code, you'll get to it as well. We also have on Wednesdays, we use Web5. We're doing some really fun ones coming up. So this is a Mean Girls Guide to Data Sovereignty. If you don't know what Web5 is, or you're just kind of curious, you've heard the buzzwords and stuff like that, you can come check that out. Rizal is a great speaker. I've had her on before, and I know it's going to be a great session. So join us there. If you have any feedback on this session or on any upcoming stuff, just feel free to email me if you want to speak, if you want to sponsor, brian@cfe.dev. Yes, this session is recorded. Everything today is recorded, so we're going to run until about 4 o'clock. It's going to be recorded. At the end of the day, it's going to be there for you. You can go back and watch. I will also post edited videos to our YouTube channel and to cfe.dev. Speaking of that, we've got like over 250. We're closing in on 300 recorded videos from 6+ years of running this. So if you're looking to learn anything, just go back through that archive. And then you can follow us on Mastodon, join our Discord, follow us on YouTube or LinkedIn. And that is it. I'm going to stop sharing here and turn it over to our MC for the day, Melissa McKay.
Hi, everybody. I'm so glad that you're here to join us. When Brian Rinaldi reached out to me to do a DevOps themed event, I was super excited about it because I think this is an important subject to talk about. And when I say subject, I mean subjects. There are several things to talk about today. We have quite the rundown of topics. We're going to be talking about, all the way from disaster recovery to integration testing to observability, possibly using distributed tracing, all the way to deployments, and then an interesting talk at the end about supply chain robots. I'm really excited for that one. I think DevOps is a super important concept that we all need to understand and know as developers, especially. I've been a developer for 20 years. I'm currently a developer advocate with JFrog, but prior to that, I did have the opportunity to be on a DevOps team. And one thing I will say is the first few weeks, months, year, it was pretty overwhelming because there's a lot of additional tools that you need to have in your toolbox. But the key is don't rely on yourself for everything. Being on a DevOps team or being a DevOps engineer, if you want to have a title like that, doesn't mean that you should know everything. It means that you have a talent for collaborating with your teammates, each of you with your separate specialties, and be able to build something together that is reliable and efficient and that you can have confidence in. So I won't talk about that anymore. Let's go to our first expert in the field. We're going to introduce Batel Zohar. He is someone I'm privileged to call as a colleague of mine. She's also a developer advocate at JFrog. And I've been all up in DevOps the last few years, but Batel, I think you've been in even longer. And she's going to talk to us today about disaster recovery. I think no matter what our processes are, we need a way to recover when things go wrong. So Batel, I'm going to hand it over to you.
Thank you. Thank you very, very much, Melissa. And hi, everyone. Today we're going to talk about ransomware DR. What is it, how we can recover from it, and more interesting information I think you should know. So first of all, let's talk a bit about disaster recovery and disasters, right? They could be anytime, in any place, in any cloud provider. And I'm going to show you some example in a second, but it always will happen when we're drinking our hot coffee or when we're just going to our vacation, or it have to be in a jinx way, right? So let's talk a bit about the clouds. I know that most of you, or all of you actually, are using clouds today. So over the years, we can see a few examples of disaster that happened to the most familiar cloud providers. So first Azure, right? There was a network fiber cut caused by some weather conditions in the Netherlands. So the servers was down. And of course, it could be all everywhere. So also in GCP and AWS, we had some network distraction during the last year. And I guess that some of you remember North Virginia that was down for a long time. Let me know in the chat if you want to share some crazy stories too or any disasters. But if you agree or disagree, it would be great. So disaster can happen everywhere and anytime for all kind of reasons, right? There is different reasons. Sometimes it's not really super important, but it could happen. And today we're going to talk about disasters and some ransomware DR and how we can protect ourselves. So first of all, thanks again for joining. I love to be here. My name is Batel Zar, and I'm a developer advocate in the last 3 years, almost 3 years in JFrog. I was an embedded engineer before, then moved to full stack, and then joined JFrog. I was part of the support team and technical account manager, and I would love to talk about DevSecOps, AI. So really, feel free to reach out to me whenever you have any questions or just want to chat. I would love to discuss with you guys. And as you can see in the picture, I have two crazy doggies, Banjos and Saul. And yes, that's it for myself. Feel free to reach out later. And I think we can start. So just to make sure we are all aligned, let's explain what is a DR, right? Disaster recovery. You probably heard about it. So it's a set of processes, policies, and procedure that an organization implements to resume its critical IT system applications and data after a natural human-made disaster. So it could be simple, right? I just accidentally remove any file that could be critical for my team. It could be much more than that, but anything that will disrupt my day-to-day work, it could be an issue. So the goal of NDR is to minimize the downtime and data loss in the event of catastrophic events such as a hardware failure or a data center outage or just power outage or cyber attack or even just, as we said before, just floods or something, earthquake or anything that is pretty natural, but it can affect us. So let's say that we have a horrible disaster in Peru, right? We want to make sure that the server on Uruguay are still up and running and everything functional as usual. So usually we would like to create a similar environment on different location, different place, different city, different whatever we will decide. It depends on the size, on the company, and different stuff like that. So we want to make sure, as I said before, that we're always up and running, right? No disruption. Everything was perfectly. Of course, sometimes it's a crazy dream, but we'll do our best together. So what is a ransomware DR? Ransomware DR is a cyber attack. Like as an example, you can't reach out to your data because it's encrypted. right? Some of you heard about ransomware before, and the attacker probably will encrypt all of my data so I can't reach out to my application, to my servers, anything like that. So I'm kind of stuck outside, right? The attacker just closed my door, and now what I'm gonna do, right? I'm just keep getting any errors or requests for some financial stuff and things like that. So ransomware is a type of malicious software that encrypts the victim's data, right? This is the official statement for that, making it inaccessible until ransomware is paid to this attacker. So ransomware attack have become a significant threat in the organization worldwide, and having robust ransomware disaster recovery strategy is essential to mitigate the impact such attacks like that. So let's take a second and think what will be the things that we need to think about when we're talking about cyber attack, ransomware, DRs, and stuff like that. So first, let's make sure that we are aligned with all the things that related to DR. So let's show the difference between DR and ransomware DR. All right, so the two main difference, of course, there is some more, but this is the main one that will help us to make some order in this information. So our DR environment will also be exposed during the attack. And so all our data main and our DR will be vulnerable, right? In case that we have any DR environment, it could be exposed to. And quiet attack, it's also very, very different between just a simple DR to a ransomware DR. So when we're talking about quiet attack, the interior can attack quietly and slowly. And then it will start to destroy or taking out our data while the organization is not aware of any issue. So think about it. It could be someone from the organization or outside the organization. And if we will imagine our cloud services, it could be someone that just keeping getting more and more information about an environment. So it could be that in the beginning, the attacker won't have all the privileges, right? He can just reach to a specific location with a specific privileges that just showing the VMs, for example, right? It just show me the names. It's pretty simple. Just read, and then after a while, he will find other places that he can reach more and more data and gain more and more privileges in that case. And that could be very, very hard to understand how long he is in our environment, what he tried to achieve, how much information he got when he was part of our organization. So ransomware DR happens intentionally, in most of the cases. Now, let's talk a bit about RPO. I guess that some of you heard about RPO, which is Recovery Point Objective, which means how much data we are willing to lose during a DR event and how much it will harm to our business. So, of course, we really would love to cover everything and make sure that we have the best DR in the world. Everything will just, if something will happen, we can just go back. But sometimes it's not that easy, right? We need to measure the amount of that data that can be lost without any damaging to the business operation or finances, sorry. So it's really hard to try to focus and understand where is this point. And sometimes it's it's even impossible, right? Like of course, everybody thinks that they are up and running and they will be safe when they have the DR, but sometimes it's a little bit more than that. Now, we have the RPO and the RTO. So we have the recovery point that we talked before. We have the recovery time, how long it will take us to get back to business, to make sure that everything is up and running as we wanted before, and how quickly we need to recover, what is the cost for the downtime. So it's a little bit tricky, and try to think about your organization and what will be the best between the two of them, right? What will be okay for a downtime? Like if 5 hours of a downtime, it's something that it's affordable, or if we'll lose just 20% of our data, if that's okay. It's not like how I should plan it for the future, right? What will happen if we'll have a disaster? How I can prevent it if I can prevent it. I'm not sure that we can prevent it. So we'll discuss about it. So as we said, cyber attack happen intentionally, right? So who will want to harm our company? So one case, it's internal attack, right? Employee within the company, like you can see in this story over here. I'll send you the link later on. An Amazon manager who stole almost 10 million with fake invoices and used the money to buy house, Tesla, Lamborghini. He's sent to jail, of course, but think about it, it can be someone from the company. You already know all the trick, all the businesses thing that you need to know, and it's much more easier than someone out of the company that would like to harm the company, right? And I guess that most of you heard about stories like someone that just got fired or something like that and was really pissed off from the situation and want to make sure that he is harmed somehow. So this is just one story. We have tons of stories and an example like that that the attacker could be an internal employee, ex-employee, or something like that. Now, the second case is just someone which is external, right? It could be any external attacker who is looking for money or looking for resources or looking for whatever. It could be a crypto mining. It could be anything that he would like to achieve with whenever he is getting to the source. So it could be someone like the crazy dictator, if you saw the movie, and he's trying to reach out. So the idea here is to get the resources and attack in that case. So as we saw, we have the internal one and the external one. So probably you are now saying, what are the chances that this will happen, right? And I'm doing all of this preventive action, like running security tools to alert an instruction, or strict policies and permission to block access, or even using SSO method, right? And there is much, much more, like tons of things that we can go by the rules and do that securely. But eventually we can't be fully protective. Even if we will try our best, I believe that there is always a hole somewhere. So there is always a way to get in. So let's try to be prepared for the ransomware attack, right? Let's try to consider what we need to think about when we have a ransomware attack. So one of the most important things to take into consideration is decoupling. Maybe some of you heard about it, some of you may not, but decoupling, I think it's one of the most important services from it. Basically, one of the most important things here that I want you to take with you. And basically, we'll decouple the important services from one to another and to prevent the attack on a few areas. So the way to do that is using different accounts. So think about it that I'm using the production environment in one specific service or account. When I'm talking about testing, it will be on a different one. It could be for different services that were up and running. For our website, we will do a specific account. For our service, the payment service, for example, it will be on a different one. And then the chances are reducing because the attacker will find one of the services. Of course, he can get to all of them, but it will be much more complicated when we're having different SSO, different password, different ways to get into those accounts. So, for example, it will be good to separate the security tools that were protecting our environment in an account with a minimal permissions, because if the attacker will reach out to the security tool, he can disable all our preventive measures to the security alert on instruction. But in another example, which is pretty simple too, is if we have an administrative interface in our product, right? We have something that's related to our admins. We would like to separate it from the rest of the services that will reduce the risk for the attacker. Will have admin access, which will allow configuration changes, right? So it's very specific for a specific component. So it won't be so harmed. So we'll try to decoupling our services. Now let's talk a bit about data layer. By data layer, we refer to the database that usually holds important data. So, for example, we have our customers' data, and in order to be protected from ransomware attack, the database snapshot should be copied to a different account. So, in case of a cybersecurity, the attacker will not be able to destroy them. So we will be protected and we'll have a clean backup of the data. Nice. A good practice will be to place the longest period as possible. But what is the longest period, right? Think about it. Like I should back up the data for a year, for a 2, for a few months. So it's really hard to understand it because we have the retention of snapshot. And if we will take time to discover the instruction, it will still have the original data in place. So what is a long time again? Right? Remember the quiet attack, it can be for a week, month, or even a year. So I'm gonna just recover the full year. It will take time to recover it too, right? It's also something that we need to think about. Or we will just take a few months, but what will happen if someone just log in or register to the system just a little bit before our backup? What we're doing in that case? So I'm sorry you have a lot of questions to think about when you're leaving this session, and I'll try to answer most of them. And another important thing is the storage, right? The storage data can be binaries, it could be logs, files, and more that we would like to keep in our storage layer. So to keep it safe, we need to replicate it to a different account. Sounds again pretty simple, right? Just a replication, just another service that will up and running. But also here, we need to take into consideration that a new version of the file could be after attack happens. And again, the data is corrupted, so we need to keep our older version or the original version of the file. And what we're doing in that case, right? Like how much we are gonna pay for it and how it's gonna work when we have a lot of data, right? Where today it's not just a few megabytes, gigabyte, or even terabyte. It's much more than that. We have tons of data all over the world, and one will be the red line, kind of, right? Like when it's okay just to keep and stop right here, or should we try to get more and more data? Should we need to back up a little bit more? So it make it a little bit more complicated. And of course, eventually the workload. We will need to move our workload to the new account to work with the data that we already transferred, right? So all this process of copy from one place from to another could take some time. So again, we need to think about it. So should we prepare all the infrastructure ahead, right? Maybe it's something that we need to do at the first day that we are just creating a new project. Should we think about the DR, copy everything? Of course, today there are great tools, right? Especially on the cloud, there is a lot of tools that help you to create a DR, and we can discuss about some tools later on. But the idea here is, again, should we just create an automation that create everything from scratch in case that we have a DR? What do you think that will be the best way? If you would like to share it on the chat, it could be cool, and we can talk a little bit about that. But think about what would you do, right? Think about the cost and the time and the idea that we don't have too much time when we have a ransomware DR, right? Think about the idea that the attacker can say something like, if you won't pay in 3 days, we're just removing all your data, all your encrypted data, and what you're doing right now, especially when we're talking about very large organizations. So we really need to think ahead what will be the best approach, what we're doing in case that we have something like that, and how to attack it in that case. Now, let's try to conclusion some of the things. I know I didn't cover everything, but we can talk a little bit about it later on. So we don't have too much time. So first, I think that decoupling the main services from one another, like I said before, the security tools will help us to reduce the risk. The second one will be how we can make sure that that data will be stay immutable over a long period of time. So, we have our database, we have our storage, and we want to make sure that we have it for a long time and it will stay there just for as much as we need. And let's think also about the maintaining the DR environments, application, upgrades, failover tests. Again, it's not something that will be so easy to maintain, right? Like even if we were thinking about the simplest scenario of just copy the same environment, right, from one place to another. We need to upgrade our services. We're upgrading our original server. We need to make sure that we are doing it the same in the DR environment. All right, so it's easy. We will just create the automation to do that. But what will happen if it's working perfectly in one environment? It won't happen in our DR, even if they are the same. Some stuff happened before, right? I guess that you will agree with me, but it could happen. And we need to decide what will be our RTO and RPO, and taking into account the cost of the selected solution. Again, like a lot of people that I talked with them about DR told me, you can't just waste, depends, but let's say it's thousands of dollars about having a case that maybe something will happen. But what will happen if really something will happen and then we need to set up our DR as soon as possible? It's also an issue, and we need to think about it, like where we're crossing the line. So what will be our exact point that we would like to recover in that case? How long it should happen and it should take to recover, and what will be the best solution here? So I hope I make some order today. Thank you very, very much for being here today. Let's see, I see that we have some Q&A. So, okay, cool.
Hey, Vital.
Hey,
Thank
Melissa.
you so much. Hi.
Thank you.
I started out listening to you and I was immediately terrified. I think this is an excellent topic for this theme that we have, haunted DevOps. But you did a really good job of giving like some real life solutions, how to tackle it without just being frozen and not know what to do. Can you, so I am not as familiar with like all the terms and everything for disaster recovery. And you mentioned a couple of times RTO and RPO. Can you go over those again, just for our audience sake, and really for mine, I'm being selfish. Just remind me what those actually are and how important they are.
Sure, thank you very much. So RTR is recovery time objective that measures the duration of time an application can be down without any damaging business operation. So as I tried to show before, I'll try to find my slide just a second, just in case. So we have the recovery time objective. And if we're talking about RPO, we have recovery point objective, which is measure the amount of data that can be lost without considerably, again, damaging operation or finance. So if you don't mind, I'll share my screen again. And maybe Brian can help me with that, or I'll just share. Yes, great. So let's talk a bit about that for a second again. So we said, first we have the data that we can afford to recreate or lose over here with the recovery point. And then we have the recovery time. So it's kind of a tricky game between the two. Like, again, what will be more important to my organization? Just to recover as soon as possible what we had before a year? Or we need everything that we are having before a month or something like that, so we can just recover quickly than just spending tons of money of keeping everything for a long time. It's kind of a tricky game, and we have the recovery time and recovery points, actually, which is the RPO. Thanks for asking.
Cool. Yeah, this is really helpful. And I actually took a screenshot of this because it's something I want to tweet about later, talk about your session a little bit. So have you yourself personally been a victim of an attack? Like just personally, a company you've worked for or anything like that?
So not exactly personally, but my husband company, just I know that they have some attack. They actually help to attack other attackers and stuff like that. He's more DevSecOps professional than me, but I try to be involved as much as I can to learn a little bit more about it. I know
Yeah.
that after I left one of the companies that I worked before they have an attack, I didn't have all the details. I just know that it was ransomware attack when it just beginning, like before 6 years or something like that. But I think it's really interesting. Like I always
Yeah.
trying to get more and more information about it, and
Yeah.
it's really crazy to see how different organizations looking for this, right? Like there is so many ways to attack it, or so many ways to try to prevent it. Even when we're in talk with our DevOps or other DevOps engineers all over the world, it's kind of a very tricky or interesting question to think about, because there is so many ways to think about the prevention, what to do in that in case it's happening, what will be the best approach even after they got attacked, how to really talk to the attackers and stuff like that. It's really crazy, like so many things to think about, and
Right.
you can't do that quickly.
Yeah, this is true. And it seems like, we come up with solutions and then attackers find a way around it. So it's probably
Right.
not something even that will remain static. These solutions will grow and change over time. But some of the things that you talked about seem to be, especially your, what did you like decoupling, things like that. It seems like those will always be a good solution, making sure that you keep things separate so that when things do get attacked, maybe not everything goes down at the same time, or you have
Exactly.
some other way of accessing your stuff. So I'm same as you. I have not personally been involved in an attack like that at an organization at any level, but certainly personally, I shopped at Target. So I remember, I've gotten several letters in the mail since then about various attacks on data. So I was really paying attention to, what you were talking about when you were talking about data, and making sure that you have redundant data and things like that. But there's probably some stuff that we need to do personally for our own disaster plans, right?
Definitely.
Yeah. So we have a lot of devs in our audience, and
Mhm.
I'm sure I'm not alone in saying that, like, even, if we go down to just our local workstation, and maybe you don't have an attack per se on your system, but have you ever, had your computer blow up on you
So many times,
and
yeah.
not have a plan for dealing with that?
Yeah, definitely, especially now. I
Yeah.
had something similar with my phone, actually.
Yeah.
It's not exactly an attack, but it just died, and I was like, all right, what am I gonna do right now? I didn't prepare a backup. I was like, everything is on the cloud, but not really everything, and it could
Right.
happen.
Yeah. So those are dangerous too, right? So not even
Right,
just attacks, but just like things that happen that slow us down.
right.
And that's one thing. So as a developer, what would you suggest? What can we do individually to protect ourselves?
Wow. All right. That's a really hard question. But first of all, the basic stuff that you already know, don't use the same password and stuff like that. Use somewhere like that can, like a vault or something, that you can have a different password that will attack your specific account and so on. Two-step authentication, all right? It's so popular right now. Everyone asks you to add a two-step authentication, but not everybody doing it so far. So please, for the important stuff like your GitHub account, for your authenticator account, for different accounts or something like that, make sure that it's up and running and always allowed, right? We want to make sure that we are as secure as possible. And of course, there is much, much more than that, but the basic one is, again, kind of decoupling of services for our own, because I don't want to have my personal stuff on my job computer, right? Just in case that one day I will just join another company or just do something else. And where is all my data? I want to make sure that it's in my personal computer and won't be really involved with other stuff. For my opinion, it's much more safer.
Yeah.
And I know
Yeah.
that there is
Agreed.
some regulation that they can see and stuff like that. So just in case, keep it on your personal stuff on different place. And I
Yeah.
see that there is a question actually from the audience. What would be a good time frame to recover? And so I think it's really hard. Maybe I would like to share some folks too, but again, it depends on the organization. It depends how big it is, how many PRs we're doing every time, how many versions that we're releasing, and what is the time frame, right? Like in case that we're talking about specific application that was attacked. If we will go one or two version backwards, is that enough? Or we should think ahead for the last 3 months or whatever? I'm sorry, I don't have the best answer, Mark, but I think that we need to take it and talk a little bit about the organization, right? What we having and what is the time frame? How many builds do we have there? What is the difference between the versions and so on? And try to think about it. I think it's really, really hard to get, or even impossible to get to a perfect time frame. But depends on how many developers we have, what we're developing, and what will be the difference between the versions. Because even today, right, we would like to keep the application as is and just add a small services each time. So maybe it's not so bad if one service will go down or it won't work or something like that, and we can just rebuild it. But again, it's changing every time. So I'm sorry, I don't have the perfect answer for that. But what do you think, Melissa? Do you think we
Yeah.
have a good time frame to recover?
Yeah, I mean, you talked about having that balance, figuring out
Yeah.
how much is it worth to you. And then, you also have to ask these questions. Is it better to go back or to move forward? So like
Right.
perhaps, just removing, let's say an attack came in through a particular package, maybe remove it altogether, or maybe do something different. But Mark, he touches on something that is a sensitive subject for us in particular, because I think we probably get approached with these questions all the time, especially about how often should I update? Let's say you have, right, like it's because it's not usually, it's not the case that all of the stuff you have is proprietary. You might be using other libraries and packages and things like that for your software alone, right? So how often, there's one end of the spectrum where you update all the time to make sure that that you don't have, new vulnerabilities creeping in, or dealing with existing vulnerabilities, things like that. But on the other hand, you might be updating something so frequently that now you can't get back to a point where you were safe. Do you know what I'm saying?
Yeah,
Or you have
exactly.
so many moving pieces now that it's hard to really tell where to go back to. So
Super hard.
so managing those builds and stuff can get tricky, but I think at the very least, having a good list of everything that is in your software to begin with, you can at least begin that process of figuring out where an attack might have come from if it turns out to be like a vulnerability in your software, for example.
Right.
So yeah, lots to think about, Patel.
Yeah, but this is a great start. Thanks, Melissa.
Yeah, definitely. I loved your conclusions. Really liked, especially what you talked about with decoupling, about redundancy in data. So yeah, I'm going to go think about this for a while and think about, even just personally at my level, just as a developer, what can I do not only to protect myself and have my own disaster recovery plan, but how can I prevent myself from, being inadvertently part of an attack or something on my own organization because of being lazy with passwords.
Yeah, I can tell you my crazy story about it. Actually, I have my smart home automation with a Home Assistant, and I was really, silly in the beginning, and I was like, everything is working perfectly, and I don't need a backup, and everything was good. After, of course, it took me a long time to develop everything and configure everything. So after I read about that, I created my own disaster recovery for my smart home. So in case that I have one of them will be down, I have the other respirator that will be up and running and get the power and all of it. But it could be even a simple stuff, right? Think about it tomorrow. Somehow the router will be down, or so you need another way to get your power outage and stuff like that. So it's not an official DR, but think about how it can help you with your something small that you're already doing all the time, and it's not for the whole organization. Yeah,
I didn't even think about that with smart homes and like your internal network. And Yeah. I was just thinking,
It's
I
everywhere.
have a daughter now that's getting really interested in coding and stuff. And, she'll
Ooh.
come visit and get on my network. And, I don't know exactly what all she's pulling down or what all she's doing. So this is probably a conversation I need to be having with her as well. So yeah, interesting. Interesting stuff. Well, thank you, Batel. Again, if
Thank
any of you
you.
have any questions for Batel, please post them here. We might have some time to catch up later. She's got her Twitter handle up here, so feel free to contact her with any questions if you have them later. And we're just going to take a short break here. We'll be back at 10:50 with Ishel Ruiz. Her talk is Spooky Connections, Integration Tests, because reality can be scarier than our nightmares. So it looks like we have more to be afraid of coming up. Thank you, Batal.
Awesome. Thank you.
Hey everybody, we are back with our next speaker in our lineup for Haunted DevOps. I have the privilege to introduce you to Ishel Ruiz. Ishel, we've known each other for quite a few years.
Yes, for
And
sure, and I'm super happy about that.
Yes, it is so easy to introduce you. Well, not easy because I have way too much to say, but Ishel is a Java champion among many other things. We've met, over 10 years ago, and I have nothing but admiration for her energy and her accomplishments. She is super community minded, cares not only about the quality of software and dev processes, but also about the people that are behind the software. So, Ishel, I'm going to pass it off to you to tell us more about testing. Super, super, important topic in DevOps. Take it away.
Thank you, Melissa. I'm really happy to be here today, of all days. So when Melissa told me about this event, I was super excited, and I only wanted to put the title Spooky Connections because I am going to talk about testing, but we will build up a little bit the topic until I reach there. So I'm Charisse. You can find her at Mastodon, LinkedIn, Twitter. I'm a Java champion. I collaborate with a lot of foundations, and I loved everything about software. As Melissa said, the human part and the technology part. That's what makes me very, very passionate. And Melissa didn't mention, but we actually wrote a book together, DevOps Tools for Java Developers. So we have collaborated in so many different adventures, Melissa and I, and technology is just one of those. So, Haunted DevOps. And it doesn't have to be scary. And I agree, because my first thought, it was like, awesome, today of all the days. Because for me, today is the Dia de Muertos. See, I'm totally ready for it. And if you know any Mexicans, and even if you saw Coco, you know that Dia de Muertos and Halloween is not something scary. It's actually something that we appreciate, we value, we find it inspiring and good. So really scary is not. I mean, when I think about the monsters under the bed, I usually think about fluffy and cute and nice. But then I remember we're talking about software, and I was like, do we have monsters under the bed in software? And yes, and then everything rushed back into my mind. And yes, and the monsters that we have in software development are not the fluffy, cuddling, nice monsters. And some of them are not even visible. So I felt exactly like that. Like, oh my goodness, this session is not going to be so happy and flowers and candles. But let's take a look closer to our monsters. Well, there are a lot of them. And at the beginning, I thought, well, it's going to be only one or two in software development. Let's talk about our monsters. And the first monster of the day, or of the night, it's going to be time. Time and numbers. And I know what you're saying. Like, Ishel, for crying out loud, they are an infinite number of numbers. So, of course, this is difficult. But then our problems are even when we count to 100. Oh, yes, so we don't have actually any skills there. But anyway, let's continue. Second monster, security. And then, oh, well, I'm actually not going to go into our monsters, but I just want to let you know the gravity of the monsters that we are hiding under our bed. But do you want a little bit of details about this particular one? Well, we had 18,000 government entities affected, and most of the 500 Fortune companies and 9 federal agencies and more than 100 companies were exposed in the first attack, of the first wave of the attack. And this actually created the environment for other really important attacks. For example, in the pipeline, in the US fuel pipeline, and the Irish health service system, and more. So It was it is still a big monster under the bed. And let's talk about format measurements. Yeah, the Ariadne 5. So this was an error that cost in that particular second 370 millions because we had an integer overflow. So 4 satellites, 2,600 pounds of the clusters in the program, and in general, the Ariadne 5 turns into smoke on June 4, 1996. And you see in one of the reports of this particular malfunction, it clearly says this could have been prevented if we had better testing. Let's talk about language, because language is there a lot and it's also not a very easy thing to deal. But there, I mean, obviously I'm talking about translations, but not only translations. Why don't we sometimes even prevent the small things like, do you want to cancel your subscription? And you will cancel and cancel. So sometimes our design, our way of managing operations, language, and intentions to our users is not the clearest one. Next monster, we were already there, usability. How much do we make our users feel welcomed and understand their different necessities? Well, for this, I didn't even show examples because if I'm honest, even my own personal site is not 100% fully accessible. And this is, there are several reasons, and most of them are going to be excuses, so no really good reasons. And the last and not the least important problem is generative AI, what the future will bring us. So there is a lot of monsters here, and by the time I only picked this because they are really fresh in my mind. These are the issues that I found day after day when I was a consultant. I was a little bit depressed, not the objective of this session. So I was, Excel, this was not the objective. We need to improve this particular session. And I felt exactly like that. So how do we actually improve this part? Because at this point, I was feeling already a little bit depressed. And that's not a good feeling for anybody, nor software developers, no DevOps engineers, no anybody. But then I remember, this is not exactly about software development. This is more as a DevOps strategy, or what our workflows. This is not flows. So at this point, we haven't decided about formats. We haven't decided about languages. We haven't decided. It's not there. Like, this is not the focus. Of course, it's part of the software development cycle. So I said to myself, well, probably here we don't have as many monsters as in software development. But again, that was not the case. And the most frequent cause for continuous integrated builds to fail is due to tests that do not pass. So again, I went back to the other side. Testing this is going to be totally important, no matter if you are a software developer engineer, or if you are a DevOps engineer, or you are in any part of this spectrum. And you know what I refer as spectrum, because in this moment about how do we build software, we are either fulfilling the roles of so many different people, or every single people has to know a little bit about the different activities and roles and operation and tasks and responsibilities of many sections of the software development cycle. So honestly, I do not think myself as just a software developer, not only a DevOps engineer. So I'm the spectrum of all those two main job roles. So testing is really important. But again, tests are not the same. They are not created the same. And when we are thinking about creating our strategy, like how much effort do we have to put to unit testing, how much to performance testing, penetration testing, how much to our contract testing, from consumer to provider, how much into integration testing. And you will, because creating tests and test suites is expensive. Running tests, it is expensive. So when we have our set of tests, we have to balance how we execute them in the time constraints, not only time constraints that we have for executing, say, tests. So it's not only creating, maintaining the commission, but also during runtime. Are these the right tests that we should be running specifically for these operations? Are we actually modeling correctly what we should be testing? So when we want to create a good testing strategy, from the decision that we have already created, from our universe of tests, either if it's a pyramid, if it's a other kind of shape, because now we are even asking ourselves, what's the right shape for our tests? Should we have more unit tests than integration tests? Integration tests are very expensive. So that's why we don't have that many. And integration tests actually are linked to the complexity of the software or the interfaces that we have. In the past, when we had to mock a lot of services for an entire class, for a single class, we said to ourselves, this is clearly insane. It's so difficult to create a mock or a stop for it. It's going to be more expensive. So we created, or we focus our efforts in creating the unit test and the functional testing. And we said, this is enough. This will give us the quality that we are looking for in our software. So this is the kind of the conversation that we will take us into the rabbit hole. And because I won't give you a percentage right now, I'll tell you, well, you have to have 60% of unit test, add a 10% of functional test, keep a 5% of integration test, but don't forget about your APIs. So add some testing there from the consumer point of view. And if you're creating your own API interfaces, create some producer kind of testing so your consumers can always download that test suite and check that your specification is still in order. So I'm not going to go in that direction. Instead, I'm going to tell you a story. And I think it's a good story. At least my skull says so. So this is a story, of course, very close to where I am right now, more or less close. And the day, it's September 19, 2008. It was Geneva, Switzerland. It actually was a very sunny day, but for the details of our story, it was not a sunny day. It was a very cloudy, sad, and cold day in that particular place in the CERN. And as you can see, there is a bluish kind of tube in front of it where it says that is the accelerating science, etc., etc. So that's actually a depot. And this year was amazing because finally, after so many years of building this particular international facility to investigate the God's particle, it was up and running. And it was up and running and everything was awesome for 36 hours. And then poof, literally poof. So what actually happened? Well, in the first picture that the first and the second one appear very fast. But anyway, in the first picture at your probably right, you will see how the ring it's created with all these dipoles with these magnets. And the second picture is what happened after that moment. So after a few hours, a few days, there were several reports, what happened, why it happened, what was the problem. And turns out that, well, on the bright side, there were enough pieces to replace the damage. On the brighter side, there was only going to take 2 months to fix it. On the negative side, well, the CERN has this incredible big building for testing purposes. So their tests were up-notch. They were amazing. They would run whatever they could think on in every single segment of the dipoles of the ring. But this building was not big enough to hold 2 dipoles at the same time, one after the other. So what do you think they didn't test? And you're right, they didn't test the integration between the 2 dipoles. And this is exactly what made poof. So one of the things that the CERN learned is that they needed to test the integration between the 2 different ones to verify that the current was running as expected, that the helium wouldn't have peaked, and literally it wouldn't have exploded. It was so strong, the explosion, that even the brackets were inside the concrete to hold this dipoles were totally destroyed. So they learned, and we learned, that integration test is very, very important. But not only that, integration test, it has to be contextual. One of the most interesting parts of one session that I attended at Google was when the head of the infrastructure team was saying about how difficult it was to test, and one of the big lessons that they learned. And one of the big lessons that they learned is that we need to test according to what is going to happen in the hands of our users. I mean, it doesn't make sense that we test in the latest machines, with the latest operating systems, with the fastest networks, in the best conditions, if our users are not going to be there. We need to test very close to reality, but testing very close to reality, well, it's difficult. Why? Because it's reality. Like, that is hard. And in our case, testing very close to reality means testing very close to the components or how things are created. So let me introduce one of my most favorite tools, and it's going to be test containers. And why is test container so fantastic for me? Well, one of the reasons why integration test is so difficult, so expensive, so that's why we try to reduce the amount, like natural. This is a natural reaction from developers, project leaders, project managers saying, like, you know what, from the things that are really, really expensive in terms of computer power, in terms of time, in terms of effort, etc., let's do the least amount of them. It was because we have so many moving parts in our current modern software creation or integration. We have databases, messaging systems, cache providers, and many other third-party services. So creating the real thing is not only very expensive, we need license, we need to run them and have them in actual good running system. So at first we were a little bit, we resisted the idea to create as many integrations as possible because it was hard, it was difficult to maintain, it consumed a lot of resources. So test containers is very useful for me because, well, first of all, it plays nice, or you can create your own test in different languages with very good support. I mean, I'm a Java champion. Well, obviously, my first tool of choice is going to be Java. But if you're working with Go, Net, Node.js, Python, Rust, Haskell, Ruby, and Clojure, this is something that you can start using. When we start using containers and running programs and running our code in testing scenarios at the beginning, because when you create a container, you usually have to expose ports, name things, etc., etc. So running tests in containers, it was fantastic. It was only one run, probably in your development environment, because of this conflict of names and ports, etc., etc. When test containers comes into play, they actually abstract all this information. And not only that, they actually added something that I thought at the moment it was the most amazing thing ever. And that was they kill and make sure that we dispose of our resources in the right way. So even as a software developer, I didn't have to listen to my ops team telling me, Excel, you kill again our machines because you have so many zombies containers here that, well, you need to make sure that your tests are terminated properly. And I was like, I resorted to a bash command that will kill all hanging containers, but this was not manageable. This was not really a good thing. So when test containers created this very fitting idea of a third container that actually were overviewing the running sequence of all my tests and make sure that regardless of what the example or the exit code of my test was, it was all going to be taken care of correctly and nicely. So it actually creates and destroys the containers really nice. And this is an example of how you can create containers and test, more or less. This is actually, I'm actually posting you some examples coming from the side of test containers. And I actually chose this one because I'm not going to show you the typical ones where test container shines, which is databases. And of course, databases are really complicated. And let me tell you the second thing that why I fell in love with test containers in the database containers. When I was creating my own, like with Docker Compose, what it would happen, I will actually have to wait for X amount, literally random amount of time until the container was set up in the right way. So obviously, random way should always create kind of a very sensation in all developers. So one of the supports that I love about test containers in the different, very specialized containers is that the health checks, the waiting strategies, it's all taken care of. So for example, when you are setting up your container, it is going to tell you, like it's going to tell your test, hey test, we are ready to go. We even have instantiated or started the database in the way that you need it for running your test. So in this case, I'm going to show you a mock test container. Actually, I'm not expecting you to read the code, so just listen to my voice. No, you can actually read it. So I'm going to tell you what is happening here. So at the beginning, we are instantiating the mock container. We are actually using a mock config JSON, and you will see why I love mock and this particular example. And then later on, we are going to, in the should get album by ID, we're going to use rest assured to fake a client. And we're going to say, when I request a specific URL, then I'm going to expect it to be correct, status code 200. And in the body should include a value, which is the ID of the album ID that I'm sending, the same album ID that I'm requesting. And then in the body has to have a property called photos. Neat, isn't it? And it's very easy. So remember that part when it says, start my watermark container with a JSON file? Well, this is the JSON file. And as you see, for creating this specific URL, mock, is as simple as this. You say, I want to create a mapping of type get that follows this pattern. This is one of the beauties of watermarks. Watermark can also be used with Java, but in this case, we are, or at least the people that created this example, is creating just JSON for specifying what the URL should be doing. So it's saying, I have album 0 to 9 with photos. And then in the JSON body, in the part of the body, it's saying like, return the ID that you are sending, of course, and also create, for example, the specific URL. So now when the test container is creating a type of watermark container, it's actually starting this container and is going to use the JSON file to create all these mappings into the watermark container. And when later on in the test, in this part of the test, we are actually using it at the lowest level, we are going to return whatever we mapped in the JSON file. And for example, if later on we want to override a specific stuff for watermark, we only need to do that. Now, whenever somebody really asks for this particular URL, what we're going to return, it's a 500. And then there is a new or even feature for test containers, which is test containers desktop. Because I had an M1 computer, Apple computer, and at the beginning, we have some issues with containers in this Apple chip. So this set me back a little bit. But then when Test Container created this functionality, so now all the tests that I was running, they could be running on the cloud. So no longer I had this problem where I had to do magic, my own development environment. It was possible for me to continue running my tests because they were not going to be executed on a specific hardware that I didn't have enough control to solve, or there were some limitations. And so in this very, very nice example that it's on the test container side, we saw obviously test containers, we should at least give it a try to create your very meaningful, very short, very easy, readable, and reproducible tests. Also have a look at watermark. I have talked about watermark with different kind of examples, programmatically, JSON, all the capabilities, the record and replay, running a standalone, running I cannot say so much about this particular tool. And finally, rest assured, because it will create your client calls so easily. So I show you 3 or more or my test tools here, or my test projects, or my test libraries that I love so much. And they are magnificent. I cannot say more praises for them. So they are actually very, very good tools. But yeah, every tool It is important, but it's not a silver bullet. And that's great. That's great that no tool is a single bullet, because thankfully there are not werewolves out there. So I really hope that at least you had a new view on something, either of our old monsters under the bed. And for the next project, one of the first things that you ask is, are we going to spend some budget into accessibility to make the site accessible, our project accessible? How are we're going to deal with dates and times and formats? What is our default programming? Our default language if you are creating a product that has to run international? Like these questions that have created a lot of problems in our industry, in our lives, and they continue to happen and happen again. I also hope that you had a sneak preview, or I created enough curiosity in you to try and see the new features. And that's the other important part. If you have already used containers, Wiremock, and rest assured, please have a look at the new feature that every single of these tools have released. Because, for example, Test Containers has created in almost half a year a new Kubernetes slide module, so you can even test your Kubernetes containers there. And monsters, yeah, sometimes they can be scary, but they are also the source of inspirations to improve, and dream, and to have better solutions for the challenges ahead. And this was my session. I hope you enjoyed. This is how you can contact me at Mastodon, at Twitter, at LinkedIn, and to see what usually I have inside my GitHub. I love feedback. I love talking to people. How can I improve this session? Because this was the first time I gave this particular session. I mean, I don't get a lot of opportunities to talk about this particular day, and I'm so excited. So how can I improve it? What should I show? What I shouldn't show? And thank you so much.
Thank you so much, Ishel. That was fascinating. Absolutely. Especially what you shared about the Hadron Collider. That's a place I haven't yet to visit, so on my bucket list for sure. Hopefully on a day when failures like that are not happening, of course. I actually never knew that about it, so that was interesting. One of the early things that you said in your talk, you said CI tests are the biggest cause for failures in your CI builds, or tests, because of tests failing. Sorry, and it just made me laugh, because I know you just recently went through a time change, right, over there in Europe. So we're about over on the US side. We're about to go through that this weekend, and it just reminds me of a time when I had a bunch of very brittle tests that were reliant on time. And they would always fail, at particular times in the month. And I'm just remembering, stuff like that driving me absolutely insane. But what you really reminded me the most is that testing is not just a simple thing. It's not something that happens after the fact, or just by somebody, a tester just sitting and banging on the keyboard. So what could help us define a better testing strategy?
Well, Melissa, I mean, sometimes we can have two problems. We either have too little tests or too many tests. Like, both things are possible. And for when you have too little tests, well, increase the number. That is easy. I mean, if you increase the things that you are testing over there, you will find errors faster. I mean, that have a test. But if you have too many, then you have even more difficult problem to solve, because now you have to think about how to reduce them. Because usually, if we have too many tests, we have, as I said, constraints. Sometimes you cannot run every single test every single time that somebody makes a commit, or every single time that there is a merge into master, which should be the case. But sometimes the nature of the tests are really or either too expensive, require a specialized hardware or something like that. So there are really sometimes critical restrictions. So what you need to understand, or everybody should understand, that there are criteria that dictates or are attached to our test, either because of how difficult it is to run the test, how much actually helps into verify the quality and behavior of our software. And so the first thing that I can suggest any single developer and any team is create this criteria, create this matrix. What is important for us, how to understand what is not only important, but necessary, and what is going to bring the most value and what is going to be the most meaningful inside our project. And from there, you start choosing the different strategies of your test. For example, you can decide, well, we will have this particular critical set of tests run once per week. But if we have this kind of changes in the code in this subsection of the paths, we will create, or we have to run this particular set of tools. If we're changing the encryption, then we have to verify this. So as you see, there has to be classification, and obviously trying to limit as much the number of tests that you are running, but keeping in mind what is meaningful and valuable. But that's only going to be answered by your own matrix of critical points and how they affect your software.
That totally makes sense. I mean, our tests need just as much care and feeding as the rest of our code base, right? We can't be sloppy with it, for sure. You've made some really good points. Well, you called out a couple tools that if you're not using them, you should be. Test containers for sure. I definitely remember being in a situation where we were using an in-memory database for everything just because it was faster. But what you just described, like there could be a suite of tests that would make sense with an in-memory database, but there are times when semantics matters, and you need to really be using the exact database that you're using in production. So test containers would have solved that issue for me years ago. That's something I recommend too, for sure. All right.
Well, the point. I was just going to add something. It's no longer that expensive, so we don't need to use in-memory databases anymore because they are fast, they are easy to start, they are easy to test. So this is the beauty of test containers. You don't longer need to pay that expensive price in terms of how much it takes to start test.
That makes sense, and good to know. You're right. Things are improving all of the time. Okay, well, thank you so much. Really great talk. Anyone, if you have questions for Ayshel, feel free to reach out to her. She gave you all of her contact information. Pleasure to have you. We will take a short 5-minute break, and we'll be back with Dave McAllister to talk to us about distributed tracing. Thank you, Ayshel. And we're back. All right, next in our lineup of Haunted DevOps, we're going to talk a little bit about observability here, and we have one of the best people to do it. We've got Dave McAllister. He is a, what are you, Dave? You're senior open source technologist at Nginx. You actually had a really clever title originally at first, a very spooky title. I thought it was a good one, but that's your official title. The talk, The Phantom Pathways of a Distributed Trace. I'm really excited to hear what you have to say. I had the pleasure of meeting Dave originally at a meetup group in Canada. And man, does he have a ton of experience, a lot of historical knowledge too. I'm going to pass it over to you right now. I know you have a lot to educate us on.
Cool. Thank you, Melissa. And that was her polite way of saying I'm an old dude. And that historical knowledge. So yes, I'm Dave McAllister. I'm an open source technologist here at Nginx, which is part of F5. Some of y'all probably have heard a little bit about Nginx. We're fairly well known in the open source world. But today I want to talk about something a little bit different, and that's around this distributed trace. And by the way, I love the theme. So if you notice, I'd like to introduce you to one of my cats, Julia, here. I am owned by 4 cats. I am completely used to being ignored. So this. But to talk about distributed traces, we have to talk about some things that are important. And one of them is why. Well, we start off with the concept that basically we're doing this for this thing called observability. And observability is things that now let us look inside of our application space, especially as it gets more complex, so that we can figure out the best ways to fix it up when it's not acting right for that. And in general, there are lots of observability signals, and these were the 3 principles. I think the number's up to 6 or something. I saw a new acronym called TEMPLE appear recently for talking about observability signals. But observability signals really break down into these 3 categories, none of which are brand new. They've actually been around for quite some time here. Metrics, do you have a problem? This is the number side of the house here. Logs, why is that problem happening? What does the application think is going on at any particular time? And then finally, traces, which is sort of the new member here. Where is the specific problem? So you can think of this as metrics for detect, traces for troubleshoot, logs to give me the root cause, the ultimate source of truth in here. And basically, it gives us the visibility into the state of the system, while at the same time giving us this reduced mean time to clue, and in terms, reduced mean time to resolution. So monitoring, which is an overlap for observability, basically keeps the eyes on things that we know can go wrong. We know that we might run out of memory. We know that we might run out of disk space. Observability lets us detect things that we didn't expect and help us explain why they went wrong so that we can move them into that monitoring category. Short, dirty point, why does anyone care about this observability? And the answer is microservices. Almost all of our applications these days are built out of lots of loosely coupled, independently deployed smaller services. They're often in different languages. They are very maintainable, very testable, because we test each section independently and we can deploy them independently. The problem is they're not all owned by the same team. They can be widespread across this. They're often in cloud environments. And because of that, the microservices add some unique challenges to our space. Basically, anyone in mathematics knows you only change one variable at a time here. Well, when we take microservices and put them into cloud, we've changed 2 variables at a minimum here. We've added microservices, which gives us a much more complicated model for this loosely coupled intercommunication practice. At the same time, we've added cloud, elasticity, and ephemeral behavior. This means that we have 2 intersecting things changing, therefore failures may not repeat. And debugging multi-tenancy can be painful. Generally speaking, and we're going to cover this a little deeper, we're talking about a lot of data. And so when we think about this, we have to think about how we move past that complicated model, that chaotic model, into this emergent practices. And that's where observability comes into play. So you're looking at what's called the Cynefin framework. It's one of my best descriptions for how we deal with things that are changing in multiple directions. And so I use this quite often. So basically, tracing is a data problem. You can think of this as tracing is going to tell you what's going on with each of those pieces. Tracing tracks an independent request as it flows through the system, from where you decided to start all the way through to its conclusion, whether it's successful or not. And that gives us the ability to have actionable insights based on the application experience or the user experience, depending on what portion we're looking at. And it also adds more metrics that are very important to us when we're looking at the best ways to approach making new things work. So what you're looking at here is a somewhat sped up red monitoring chart. Red states for rate, duration, rate, error, and duration. And as you can see here, I've sped this up, but I was looking at somewhere around 14 to 20 requests coming through per second. The average latency in this case is somewhere around 280. And my error rate goes from nominal all the way up to 21%, I believe is the high end. I'm also seeing a strip chart approach. So I'm actually seeing the data as it comes into the system. Keep in mind that tracing is an individual piece of information. Every single request is a trace, and that trace can be done. But data is only useful, in a sense, when we can aggregate it, analyze it, and then generally visualize it. And so those things give us the ability to look at new alerts, new debugging, and give us that faster time to clue and to response. But it's lots of different models that can come into play around a tracing functionality. We can have RUM, real user monitoring, actually tracing the behavior of a user through the system from start to finish. We can have synthetics, which do a similar thing, but use a known trace, a known structure, so that we can now compare across upgrades or deployments. We can actually start comparing the changes in our behavior from a user viewpoint because we're using something that we've already baselined out. We can have network performance monitoring, how the network performs across a trace. Keep in mind that we are usually talking about a remote system, a browser, to a backend system through a loosely coupled network of application of microservices. And so network performance becomes incredibly important inside of that. We can have application performance monitoring, showing us basically what the back end is doing at any particular time. And then underlying all these things, because as much as we'd like to think so, we still have to have infrastructure that we run on. And so each of these things is driven by an observability signal. RUM, synthetics, network performance, and APM actually make heavy use of tracing behavior. And so tracing behavior drives the way we now look at the application model. So anyway, why we are looking at this? This is what it's really all about. So there are tracing concepts, but the tracing concepts are pretty simple. Let's start with the basic item of work, a span. A span is the discrete unit of work in your system. And that can be an application, a microservice itself, or it can be a portion of the microservice. So each of these pieces can be defined as a unit of work. The trace is all the spans for a specific request all together. And that trace is unique inside of your system. There is only one and only one trace that matches to those pieces. And then you can also add to it other things, distributed context, where it's coming from, what tags you want to add to it so that people downstream can understand better what the structure is and what the underlying pieces look like. You can also add options, things that you want to have carried over across each of those pieces. So let's take a look at a trace. And this is an acyclic, a directed acyclic graph. And it's a standard way of looking at trace behavior. In this case, I'm looking at the trace behavior going through the system of microservices. And each of these pieces adds specific information. So in this particular case, each of my little circles is a microservice or the service application. And you've got inside of that how long the application itself took. Each of those pieces will tell me. This is actually not showing an individual trace, it's actually showing an aggregate viewpoint for that. I'm also seeing the pathway where each service sends its next step. You've got a piece of work, that span. Where does the next span go to? And as you can tell, each of these pieces goes to a different microservice, sometimes multiple microservices, and each of those communication pathways also has an amount of time that it has to deal with. And so in this case, API sending off to catalog takes 72 milliseconds, sending off to, I think the order form is 212 milliseconds. And you can see each of the pieces as they go out. Inside of this, depending on the visualization model, you may get additional information. You may get error rates, or you may get size of connectivity, how much data is flowing through it. Visualization is kind of left and is completely separate than the creation and formation of the trace data itself. So once we're in a trace, we can visualize it in lots of different ways. We can massage it. We can deal with all sorts of interesting statistical approaches. So this is one of the ways of doing this. And this will clearly show you the pathway and the connectivity between the pathways, especially when it's multiple elements. Now, the next side of that, and the other side you'll see, is a standard trace waterfall plot. And the trace waterfall plot starts with, if you will, the trace itself being called. What's the top level environment? And that is the piece that has to extend until the complete work structure ends, times out, or receives an error. Underneath of that, you will see broken down. You'll see the spans, and inside of those spans, you will see also additional item of work where they are being called out. And so in this case, we can look at this and say API called off to the HTTP request, which called to the catalog, which called to the authorization. The authorization return came back and went back through this. And we can see how long that took, in this case, roughly 33 milliseconds. At that point in time, we were authorized and went to the next step for this, which is starting to look at the catalog because it now knows that the person is the right person. And those two major spans, so have children spans. So the trace has a span. Those spans can have subspans underneath of them. And the two traces them together add up pretty closely. That's about 2 milliseconds off from that point. You can also take that same trace data and look at it and say, how much time was spent in the application? How much time was spent in a database? How much time was spent on the network? And each of these pieces will give you additional information specific to where your activity is happening and where your time is being spent. Now, how does that magically work? Well, it's this thing called baggage. And observability, in particularly the tracing side, includes this thing called baggage. And baggage is contextual information that's passed between spans. Consider it a key value store that resides along with a span context that makes values available to any span created within that trace. And it uses the thing called content propagation, passes baggage around. Content propagation basically makes sure that you are in a safe store place to do that. Word of caution, baggage should be used only with data that you are okay with potentially exposing to somebody who looks at your network traffic. It's stored in HTTP headers alongside the current context. So it's not a protected environment. It's not an encrypted environment outside of the pieces that can't be seen. There is no integrity checks to make sure that the baggage items you're getting are the baggage items that you are yours. And so you have to make sure that you're getting the right baggage concept. So with that, that's a very quick viewpoint of what tracing looks like. Well, even though this is a very complex world, it puts out a ton of data here. It's really useful. So what do we need to make this tracing stuff work? Well, each trace has to be unique. You cannot duplicate trace IDs. And you have to be able to propagate that trace ID through all of the span activities. So you have a trace ID, you have a span ID, and they have to flow together to make that happen. Once we have that, we have to bring the data together, this consolidation structure. So we bring the data together and ship it to the right places. We want it to be distributed environment capable. We're talking about cloud work here. We'd like it to be standards based. So agents are good, cloud integration is good. And in personal case, closer to open source, the happier I am about this. We'd also like to make it as easy as possible. An automated code instrumentation, because we have to put the instrumentation around tracing into our application for that. And bottom line is we want any code at any time. So the first concept of this is APIs. And there's actually a very simple set of APIs that go into every one of these. Every language has to support each of these concepts. The first one is the trace provider. We get a trace point. It's access to tracers. It sets up the global provider. It can set up others, but it's the thing that actually lets us talk to traces. And then the tracer creates the spans. It creates that unique concept, and it delegates getting the active span, and marking a given span is active to that content propagation system. So that span information gets passed correctly and context gets passed correctly. And the span is simply the piece that traces the specific operation. Keep in mind that you can actually trace just between applications. You don't necessarily have to trace within an application as well. So when we enable this, pretty straightforward. There's two basic options. And I just kind of mentioned one of them, service and traffic inspection. Traffic inspection lets us think of it as a service mesh, lets us look at how the request is being passed from service to service. And so we can look at how long it's taking to get from a service to a service, as well as how long it's spent inside of a service. What we don't get is what happened within that service. And so it's a set of information that will show us the behavior of our products, and it will show us, highlight the spots where we may be having problems, but it won't give you a really tight, detailed within that application or that microservices app itself. Code instrumentation is the next piece. And code instrumentation actually gets into the code and adds the specific information that you want to trace the behavior, the units of work within that microservices application or larger application. This is not limited to microservices, even though we tend to talk about it in that way. But when we start doing this, we have to do certain behaviors. We have to focus on the code, which means that we have to have the code, the license, the language of interest, all those different pieces. And we need to focus on the different pieces that are important to us. And so focusing on the code side here, you add the client library. And I think if memory serves me correctly, currently we support about 11 libraries as native libraries for OpenTelemetry for that. In tracing, there's only one that is not considered to be stable. In other words, ready for production for that. Once we've done this, we want to make sure that our library is in place. We focus on the service-to-service communications, and then we can add the things that we want to add. For instance, we did a piece on adding OpenTelemetry to a microservices application after the fact, production level service. And we found that it was really useful to tag the trace ID into our log IDs and tag the trace ID into our SQL calls. So each of those pieces gives you additional capabilities and additional information that's important. So what this basically means for traces, you instantiate the tracer, you create the spans of interest, you enhance your spans, and you configure your SDK. This is where life can be a little bit interesting. There is this thing called auto instrumentation, automatic. Just add the appropriate files. If you've got Java, you can just add the Java instrumentation directly to it, and you will get all sorts of tracing data coming out. It is very language dependent. Not all languages have this, and some of them you will have to go in and actually do coding for. If you're doing the manual side, import the API and SDK, configure the API and SDK, create your traces, and it's very straightforward, but you will need to go and change the code, create the metrics of interest. Again, if you want red, make sure you're getting that, and then send your data, export the data that's being created to the right place. You can use automatic and manual at the same time. What you can't do is use two different automatic interpretations at the same time. That will give you some really strange results. Automatic, your results may vary wildly, and you may actually not get what you expect you're going to get, and you may get a lot of data, and that data itself may be challenging to figure out what it's actually trying to tell you. But your apps have to be instrumented to get the correct observability signal. If you keep a quick flashback outside of traces, logs, and metrics, you're probably already instrumented for logs and traces, or logs and metrics. Here you're adding traces to that structure. So what are you trying to solve? Well, if you're looking at things like performance issues, if something is running too slow, traces are amazingly good at helping you understand what and why, as well as where things are running slow here. So are you having problems with time to resolution or time to detection? Well, traces, because it is looking at each request independently, can help you determine when things are sliding out of line for this. And then, as I mentioned before, sometimes it's kind of nice to know, particularly in a microservices ephemeral environment, where things are happening. So metrics are great for numbers and alerts. Logs give us what the application does, but traces let us know where something happened. And so adding traces to our metrics and logs provides us this context about where in our structure things are happening. And bottom line, the more data you have, generally speaking, the better your answers. But do you really need all of that data? So you can either have a span for every single thing, or you can have a bare minimum. So again, you could come back and go, I'm just going to deal with it from point A to point B. I want to know how long things took between it. Or I can deal with it and say, I want to know every time a specific unit of work or an event has occurred inside of the application space as well as inside of the environmental space. Generally speaking, it's best to start with your service boundaries and third-party calls. So understanding, again, how long the propagation happens between the services, as well as how long things took overall without going into each application space. This is really useful. The nice thing is you can treat this as an iterative process, which means you can build minimal and then add to it as you discover things that you're interested in. That means that you can constantly upgrade and improve your observability using traces to get specifically the things that you would like. The bottom line is you really have to be careful about information overload. This adds a lot of data. Think of it this way. A trace is like a log file. That log file, that log entry itself now has anywhere from one span to potentially hundreds of spans. And so your data overload for coming from a trace can be pretty massive. Make sure that you're getting the right data you need without having to necessarily get every piece of data. As an example, a former customer, previous company, for that was creating 43 terabytes of log files an hour. Fairly large cloud and type environment, you might say. They added traces to this and they basically turned on everything. That number went to 92 terabytes per hour. No one can absorb that much data. And in fact, it's even hard to visualize that data in a meaningful way. So beware of information overload and keep in mind that sampling is not the answer to information overload, because sampling is simply reducing the amount of information you may be seeing, but not necessarily giving you the correct information. So distributed tracing gives you insights into its application and to its infrastructure here, but it requires effort. You have to be able to build something. The thing is, you don't see a win until the project is basically instrumented. And so that work aspect can vary from automatic to manual, can vary across the service mesh, but it is really useful once it happens. And there is a startup process that can go across that. Tracing is this great thing for user happiness. It's a proxy for understanding what your users are doing. But tracing does not magically solve any of the issues you may be happening. You are still going to have to deal with those pieces. And in fact, my favorite quote, the most effective debugging tool is still careful thought, coupled with judiciously placed print statements. Distributed traces are our new print statements. Brian Kernighan said this for Unix and beginners in 1979, and it's still just as valid here on October 31st, 2023. We are required to think about the data that's being given to us, as well as the places that we can make use of that data to improve our applications and our users' experience. And with that, I'd like to thank you for listening. I'd like to thanks for coming out on Spooky DevOps Day. And if you need to get a hold of me, I'm Dave Mack on LinkedIn. My slides are all available on GitHub, DW McAllister on GitHub. And you can always find me on Nginx Community Slack. And with that, thanks. And I will hand it back over to Melissa here.
Awesome. Thank you so much, Dave. Your presentations are just packed full of information. So I'm very happy that you shared your slides. I'm sure there are many in the audience that are going to be looking at those later. Something you said struck me just at the end there, just that you have to be thoughtful. And I do remember in the early days of my career where print statements were all I had to hang on to. That at least that's what I used until I learned better tools, of course. But it seems like we should probably be thinking more about, in order to take advantage of just the benefits of observability in general, we probably should be developing with that in mind right away, right? Like,
yes,
maybe not try to put it on at the very end. Maybe we need to start rearranging our thinking and starting with it first.
absolutely. If you can, build it in from scratch. And that's actually where the most successful observability exists today. We at Nginx took this banking application, which exists microservices based, and basically said, what's it going to take to add OpenTelemetry to it? And we regretted our lives for about 6 months. When you think about architecting, you as an architect should know where the units of work and how they plug together. When you just built the application, what happens is people don't actually think about units of work and how they put together. And so it just magically happens. And so tracing, if you build it, when you do this, you'll have this great roadmap for what's going on in your app. And it's a lot easier to build a greenfield application than to try to go in and dig up the graveyard and add tracing to the corpses.
Right. So unfortunately, a lot of us are in this position trying to tack it on at the end. It sounds like you've had your experience doing that as well.
90% of the world.
As painful as it is, just because of how things are when you start, do you recommend OpenTelemetry? Is that something I could use today?
I actually recommend OpenTelemetry wildly, and it is incredibly successful. OpenTelemetry is used in so many production applications. Keep in mind that OpenTelemetry was the blend between OpenTracing and OpenCensus. OpenCensus came out of Google's experience for basically 5 years running production. And OpenTracing had been around by the time they merged together for, almost 8 years. And so both of them were heavily baked for tracing. When we added metrics and logs to it, the rules vary a little bit. And by the way, let me also add to this, languages matter. In tracing, it's pretty much stable. And you can use tracing pretty easily, with the exception of Rust. I think Rust is still in beta for tracing. Metrics, mostly stable, but there are some exceptions inside of that because we're coming out of strong metrics environments like Prometheus. And so we can use Prometheus metrics. Logs have just hit a stable definition. And so logs are a little more challenging right now to put into the overall picture. But OpenTelemetry is the choice. Everybody, all production applications that I know of, nobody uses anything that's not OTel-based these days.
You talked a little bit about auto instrumentation, and I can think of a few reasons why you might not want to go that direction instead. But I want to hear that. I want to hear from you and get some validation, my own thoughts there.
Yeah.
Why wouldn't you use that?
Yeah. So the problem is not that auto instrumentation doesn't give you really cool traces. The problem is that the amount of data it gives you is ridiculous, and it's probably not the data you want. So we'll use Java as an example. So you can just add the correct jar file to an application, and magically you will get traces. And the traces will be 150 spans long. And buried in that 150 spans might be 2 pieces of information you want to get, and nothing that, in that 150 spans, it's going to miss the 20 pieces of information that you really want. And so the nice thing about auto instrumentation is you can, cross my fingers, generally turn off things you don't want. But what you're going to do is auto instrument it, turn it on, go, oh my gosh, look at all this data. What am I supposed to do? And then go back in and start configuring and turning off the things you don't actually want. And then you're going to have to go in and manually add the things that you wanted to see that it didn't give you in the first place. So, when we did it for the Mara project, we found very quickly that we really wanted the trace to know what the database call was when it handed off to the database. The database was 80% of our time, and the database was 80% of our problems. So what trace was causing the problem? And so we had to go in and manually instrument so that when we saw a database call, it added the trace ID to it and logged it off for us. So, and by the way, some auto tracing tools are better than others, but Java is one of the ones that's the most complete. But this is where completeness may not be your friend.
Yeah, everything is not always better, right? It just sounds very familiar to some of the struggles I've had with even just logging when, starting there, even just trying to figure out what's going on with your system with just logging. And then finding out that, oh, we weren't so thoughtful about the type of logging, whether it was really important or what level the logging was on. So when we had to turn everything on, it was overwhelming information. And, we were in this business of shipping logs, so at least we had that part down. It was good. But the amount of information was incredible, which leads me to think that this is a similar problem with tracing. You can get too much information, right? I think you talked a little bit about that. Can you elaborate on that just a little more?
Okay. So I kind of stated this, sort of buried in this presentation. Remember that trace is an individual request. And in general, from a DevOps viewpoint, we're actually not too concerned about the individual request. We are concerned about the behavior of our system. I used to use it, and I threw up a little line about proxies, user proxies, user happiness proxies here. A user cares about their request right now, how long it took, and whether it was successful or failed. When we get into it from a DevOps viewpoint, we're concerned about the users, their cumulative request, and what the success and failure rate looks like. So if one user out of 10,000 has an error, we as DevOps may not really care unless it's repetitive, okay? That user cares a whole heck of a lot, just to let you know. A user really cares because his request didn't go through. So what can happen is we can start seeing behavior. We're seeing 15% failure rates across our user request environment. Let's go cumulatively look at those. The difference is tracing lets us actually group those things together and get the aggregate viewpoint. And so we can now start using exponential distribution models to start predicting where things are, or we can use Bayes' theorem. I do a talk on stats recently. Bayes' theorem to say, oh, things are going bad. It's probably the database. So a probability space comes into play. But otherwise, think about taking your average application, putting tail minus F on the log file, and tell me how much information you get scrolling across your screen. That's what tracing as independent viewpoints can do. And that's why we have to aggregate so that we humans can actually understand something that's going on and what the trends look like.
Yeah, that can be really overwhelming. So with all, getting all of this data, can you give me an example more of how we would know that users are okay? Like what's a good example of some tracing we'd want to pay attention to?
Okay, so there again, you think of it from the end user viewpoint, and it's how long it took. And so I'm going to start with that one. Generally speaking, and Google I don't know if they've done it this year or not, but every 2 years they did a study that says, how long is a person willing to wait for a request across the internet to complete? And the answer is 3.7 seconds. At 3.7 seconds, you're likely to have the person leave your site, especially in an e-commerce environment. They'll abandon their carts. They don't care anymore. 3.7 seconds. So if you start seeing requests regularly cross 3.7 seconds, and your e-commerce, you have a lost sale. And so start looking at it from that view. The other side is using something like synthetic monitoring. So synthetic monitoring says, I have a request I'm going to throw in the system, and I know how long it should take. It's going to take 158 milliseconds, start to finish. And you do a new deployment, and all of a sudden that 158 milliseconds goes up to 1.5 seconds. Okay, that's another red flag that you can look for. That's an individual trace result. So aggregation, look for the outliers that are crossing your boundaries of interest. If you're looking at a user, 3.7 seconds is a long time, by the way, on the internet. Maybe look for something that if it's taking you more than 2 seconds, figure out why for that.
It's amazing how much our patience has changed over the years, right? That number just goes down and down, doesn't it? We used to be.
Well, again, we used to have this thing called woodpecker, which the old terminal models, somebody would type their command in and hit the return key, and the system would go off and think about it and would come back. And the person would hit the return key again, and then it didn't come back. And they end up hitting the return key, and we used to call it woodpeckers because they do this with the return key like this. And then the system would respond to it and see 128 returns, and it would scroll off the screen. And so they'd have to start all over.
Nice. Yep. I think I've been guilty of that myself, I'm sure. Okay, this is a very selfish question because you're with Nginx. I use Nginx and have in the past a lot of different projects. Is it instrumented for tracing?
So what we did is recently built on what's called the Nginx Open Telemetry module, open source functionality. There's also a community module. The community module will show you what's going on with Nginx. The Nginx model shows you the behavior of your request through the Nginx system. And so we actually found when we went out and talked to our users, because we're open source as well as commercial things, we don't talk to the users. The users want to know what the behavior is through our system, not what our system is doing. So the Nginx OTel module was designed to literally trace the behavior of the request coming through the Nginx system and attach it into your trace functionality. You can find it on GitHub under Nginx Inc. Look for just do a search for OTel and it'll show up. And we would love to get your feedback on it.
Awesome. Good to know. All right, Dave, thank you so much for sharing. Once again,
thank you, Melissa.
Talks are always valuable information. I'll be checking on some of your slides again later. Thank you for coming on this Haunted DevOps series. Hope to see you again soon, cross paths again, and we'll
be in touch. And thanks to everybody who's tuned in as well. I really appreciate it. Thanks. Bye.
Bye. All right. In about 5 minutes, we'll be introducing Brett Smith, the software architect with the SAS Institute, with his talk, Supply Chain Robots, Electric Sheep, and Salsa. Oh, sorry. I'm wrong. Brian Benz. First, we need to talk about deployment. Then we'll get to the last talk of our day. So we are in about 5 minutes or so, we'll be bringing Brian Benz on to talk to us. Hey everyone, back from our break. All of this DevOps talk, we absolutely cannot forget about deployment. So we are going to introduce to you Brian Benz. He is a cloud advocate at Microsoft. Hello, Brian. Good to see you. Hey,
Likewise.
yeah. So your talk today, bewitching deployments using AI to deploy Java apps to Kubernetes this Halloween. I love this topic. So not only are we going to tackle the difficulties of deployment, but how is AI going to make this easier for us?
Oh, gosh, I'll show you. First of all, for those of you who are passionate about YAML editing, and I know there's a lot of it out there, that you might be disappointed at how well the new AI tools actually create the YAML for you. And that's some of the things I'm going to demo today.
Awesome.
I'll demo a couple of other things as well. Translating between languages, translating between scripting formats, and things like that.
Cool.
So, yeah.
I'm
Sorry, go ahead.
No, that's okay. I was just going to say we've collaborated on demos before. I am really interested to see what you have cooked up for us, for sure.
Thanks. Yeah, it's great to see you again. It's been a while. Yeah, we go way back. So different things we've been working on over the years. So that's great. Yeah, should I get started? Or?
Go ahead.
All right. Okay, so I think we have about 30 minutes, and then we have 10 minutes for questions. So what I'm going to go over today is basically how you actually create and deploy Kubernetes. And I'm going to use AI to actually generate the Kubernetes deployment itself. And I'll show you how to do that in just a sec. So what we're looking at here on the screen, this is the Azure portal. So I work for Microsoft. I'm a cloud advocate, and I'm going to show you Azure today, but a lot of the things I'm going to show you here are applicable to any cloud platform or anywhere you're deploying to Kubernetes. But anyway, this is the cloud portal that we have for Azure at portal.azure.com. If you aren't familiar with it, you can sign up for a free trial at portal.azure.com. And all of the code I'm going to show you today, by the way, if anyone wants to follow along at home, is at, there's a GitHub site that I can show you. It's right there. I just put it in the chat, but it should show up in the chat. But basically it's github.com/bbens/cfe-dev/haunted/devops. And I've got some scripts in there that I'm going to be using. So if you want to follow along with that, it's okay. So there's two ways you can create Kubernetes in Azure. You can go through the portal here, and I can just go click here and do it manually through the portal by pointing and clicking. If I go into containers, I can go create a Kubernetes service, and it'll create a Kubernetes service. I can connect a container registry to that as well, because you need a container registry to deploy things in general. Or I can use Docker Hub to deploy as well. And I'm going to show you how to do it with Docker Hub today. And it'll actually generate what you see here. So this square here is a resource group that we have in Azure. And the resource group here has a Kubernetes service that I already pre-created. It has a container registry that I already pre-created, and it's got some monitoring, Grafana, and some other things that you can use to track your Kubernetes deployments on this instance. A little bit about the Kubernetes service we have. You can deploy to Kubernetes on virtual machines on Azure as well, of course, Linux or Windows. But Kubernetes itself can be run using our Azure Kubernetes service. And basically what that does is take the control plane, the management plane, and manage that for you. So automatic upgrades and management of your nodes and all of the things you see here from monitoring, et cetera, are built in. The nice thing about that is you don't have to manage it yourself, and you don't have to worry about upgrades and things like that. It'll actually take care of them for you. All you need to focus on are your nodes and your pods and ingress and things like that. It's very handy, and there's no extra charge aside from the storage that you use. We don't charge for the service itself. It's just a additional offering that we have. So anyway, that's enough about our Azure Kubernetes service. So there's a way to do it through the portal. There's also a way to do it through the Azure CLI. You can also do it through Terraform. I'm going to show you some cool stuff about that later as well. But here's my clone of the repo that I showed you earlier on GitHub. And basically, this is the README. And I'm going to go through here and we're going to do a few things in our steps. And then I'm going to show you how AI can help you do this as well. So first of all, you set up an environment, you create an Azure Kubernetes service, you create an Azure Container Registry, and you deploy Cassandra to the Azure Kubernetes service. There's a couple of prerequisites. You have to have a Azure account and you have to install the Azure CLI. The first thing we do is just set up some environment variables for our resource group, for our Azure Container Registry, and for the source image that you're going to use for the virtual machine that runs your container registry. I'm sorry, your container Kubernetes service, not the container registry. Then you create a resource group using the Azure CLI. You create an Azure Kubernetes service. And like I say, you can do this through the portal or through the script. And AZ AKS create. You use the resource group you set up, you name it, you set up a location, you set up the VM size that you want, a virtual machine. And by the way, we have both x86 and ARM64 images that you can use for your Kubernetes service. So if you want to use ARM, it's a little bit more power, a little bit less power hungry, a little bit more sustainable. That's a cool option to do as well. We have Ampere-based ARM64 Ultra images pre-made that you can use for Kubernetes as well as any virtual machines or anything like that. We're just going to set up one node count and we're going to generate SSH keys. And that allows us to get our credentials easier than creating a manual key. So the next thing we do is AZ AKS install the CLI, and then installs the kubectl CLI into our Azure AKS service. And then you get your credentials, which I've already done. By the way, I'm looking at this in Visual Studio Code, and that's going to be pertinent in a minute. Visual Studio Code is a free download for those of you who might not know. If you just search for Visual Studio Code, you'll see that, or VS Code. Then you set up your credentials, AZ AKS get credentials, and it's going to set up the credentials so that you can use kubectl directly into your newly created AKS cluster. I've already done that as well. And then you can create a Azure Container Registry. Like I said before, you can use Docker Hub, or you can use a container registry. And the container registry here is, in this case, a private registry. You enable admin, and that means that you have a username and password for this. Then you can log into that container registry. You have to do that so you have access to it when you're actually going to start pushing things to it. Next thing up is you attach the Azure Container Registry to the Azure Kubernetes service using this command. You just AZ AKS update, and this is the pertinent part of that. Attach ACR, and so that's going to connect the ACR to the AKS so they can authenticate and work with each other. The next thing we want to do is we want to grab Docker. We want to use Docker to grab Cassandra. We're going to pull Cassandra in using just a Docker pull command. And then you're going to tag it and you're going to push it up to your container registry. This is optional. Also, if you want to deploy from Docker Hub, you can just deploy like this. Now, this is where we get into the AI part. So I wanted to skip over that stuff really quickly if it's not obvious. Everyone can check out the script and the portal. There's lots of instructions on how to set that up. That's the basics. Now let's get into the AI stuff. The AI stuff itself, if you notice over here in my repo, I don't have any YAML files or anything, and you need a YAML file to actually deploy this to Kubernetes. So for that, I want to introduce you to something called Copilot Chat. So those of you who are familiar with Copilot, if you're not, it's basically autocomplete that is very, very, very enhanced. You can create whole pieces of code, which is nice. You can create whole classes. It'll generate code for you, basically. But another thing that you can do now is Copilot Chat. So everybody's familiar with Chat GPT. You might have heard of it. But if you haven't, look it up. I'm pretty sure you are. Those of you who have seen it know that there's sort of a chat function. You can ask questions of ChatGPT, and ChatGPT can actually reply with answers for things you're looking for. Well, Copilot has now integrated chat into Visual Studio Code, and there's a few other IDEs you can use as well. But we're going to focus on Visual Studio Code today, and there's several slash functions that you can use. Now, those of you who might have been around for a long time, like myself, the slash functions are kind of interesting for me. I am old enough to remember when Lotus 123 and Excel used to have a slash menu. Actually, a lot of applications used to have a slash menu. And this kind of brings back a lot of memories for those of you out there who might have been familiar with those. It was just a way of basically hitting slash, and it would bring up a menu with a bunch of different options. And look at this. We've got a different setup for the same thing. Let me zoom in a little bit so folks can see this. So there's several slash functions that you can use that will help you work with your code. There's help, there's tests, simplify, fix, explain, VS Code, create notebook, create workspace, and clear. I'm going to go with a couple of these today, which is basically explain. And well, I've never used fix before. My code always works. It never. No. Anyway, and simplify. Of course, my code's always as simple as it could be. And I'm sure most of you out there are the same. But these are great tools. If you have some code that you just can't figure out, you just do slash explain, slash fix, slash simplify, and it actually brings up some pretty good suggestions. But today, we're just going to work on the code generation. And what I can do is I'll just grab, one of the things I should mention that this has an advantage over ChatGPT is context. So it knows right now that I'm in a certain file. It knows that my cursor is on this line, and I can actually select things and or ask about these other open items that I have here as well. But right now it knows that the context is here. So without much context, what I'm going to do is I'm just going to say, how do I deploy this to Kubernetes? It's looking at seeing what I'm working on right now. Okay, so to deploy the Docker image to Kubernetes. Yeah, you see, now this is why I like doing AI demos. It doesn't always, it's basically kind of guessing what I want to do, but it's not really getting it. So let's try this. Select that. Sometimes you get a different result depending on what you do. AI these days can be very capricious. And let me say a little bit about experience. So everyone, there's been a lot of talk about, is AI going to replace developers? It might. Here's my take on that. I don't think it's going to replace developers, but it will help junior developers learn, and it will help senior developers be more productive. And the reason for that is I just need to know what's real and what's not. So, you ask a question a dozen times, you can get a dozen different answers from AI. And when you do that, you have to know what the right answer is. You have to have some experience, and or you're going to learn which one of those things is the right answer if you don't know. So that's my take on AI. It's not going to, it's really going to help, but it's not going to replace developers or admins or anything like that. So let's ask again, how do I deploy this to Kubernetes? Now, last time I could just select the line and it figured out what I was trying to do. This time it basically took a shot at it. Okay, so this time it knows, okay, you're doing a Cassandra and you want to deploy Cassandra. So you create a file named deployment YAML. You add the following content and API version. It's a deployment, and then a Cassandra deployment. It's using the Cassandra app labeled Cassandra. It's going to use the Cassandra latest image, and it's going to set up a container port of 9042. That's all right. Okay, so I need to know that this is correct, right? if I do this, then what I can do is I can insert into new file. And now I can name this file. And I've got a specific thing I want to name it because I already have the prompt set up down here. Cassandra deployment YAML. And I'll show you why I'm doing that in a second. Okay. File, save as. And it's going to go to GitHub. Cassandra deployment YAML. Okay. And then it said, what did it say to do? Okay, so you can say kube control apply, deployment YAML. Let's do that. So I'll bring this down here. And it's in Windows subsystem for Linux. Oh, wait. All right. So it's created a deployment for me. Great. All right. So it's deployed that. So now I can do things like, it's going to take a second to run up, to start up, but basically I can do a kube control get pods. Okay. So there it is. It's running. I should have showed you this before, but there was absolutely nothing on this Kubernetes cluster. So I actually took a big chance doing a live demo with AI, but basically you can see how easy it is to generate that deployment and that YAML file. But the other thing we want to do is, and this is once again where experience comes in, right? So get services. So we have one service called Kubernetes. It's a cluster IP. So we need to add a service, right? So the deployment's there. We've got 3 pods. That's nice. It's exactly what it told us it would deploy, and it defaulted to 3 replicas. So it's there, but how do you actually access this thing? Now there's 2 options. You could use it as a backend database, and you could build an application that runs on top of this and connects to the database. So you don't need access to the database directly. But let's say you want to access Cassandra from HTTP. Well, you need a Kubernetes service for that. So let's ask again, how would I, it keeps the context, I hope, I deploy a service for this. Okay, so deploy a service in Cassandra. All right. So deploy a service for your Cassandra deployment in Kubernetes, you would typically create a Kubernetes service configuration file. Yes, okay. And it creates the network rules for exposing your application to other applications or external users. In this case, we're going to create this service. We're going to, once again, insert into new file. And we're going to name this one Cassandra Service YAML. I'll save as. Save. Okay. So now we've got a Cassandra Service YAML. We go back to the README. We can say kube control create. And it's actually going to create a service. So the service is now created. So then I can say, let's do this one again. So we've got our pods here now. We've got our pods running, 3 pods. And then we can say services. So now we have Cassandra running, and we've got a cluster IP address for that on port 9042. So you can connect to this from an application or internally, and everything should work. Okay, so that's basically what we have to set that up. Now you see how easy that was. So this is how AI really helps you when you're looking at deploying things. So we have a Cassandra service, we have a Cassandra deployment, and everything's up and running. So what are some of the other things you can do with this? So one of the things I was going to show you as well, this is all in the Azure CLI, which is very specific to Azure. But what if you want to have sort of a multi cloud deployment for this? The Kubernetes infra.az CLI is the actual command that I've created that edits and builds this for you. It basically goes through, by the way, the little bit of trivia, let a lot of folks know this, but the AZ CLI extension can be used in Visual Studio Code and other formats for creating resources and things like that that are going to be used in an Azure CLI. And it helps with type ahead and with other things as well. So AZ AKS create, the resource group itself, I can convert this, for example. I can say, so I've got this open now. Let's go back to our chat. And without asking it, let's change in the context or anything. How would I execute this and spell it right in Terraform? It's going to look at this now. It's going to go, oh, okay. So it knows it's an Azure CLI script from the extension and a few other things. And basically, it's going to create Terraform for me to do this, which is kind of nice. So initialize the directory in the main TF file, Terraform init, Terraform apply. Tells you how to do every step. And it creates the things that you want to name it. And even gives you some suggestions here on basically how would you actually deploy this and connect to it. What else can I show you here? Pulumi as well. So you can do, by the way, you can do up arrow, just like, those of you familiar with Bash, Pulumi. So you can do the same thing for Pulumi. So you create a new TypeScript base program, and it'll actually create the Pulumi for you. So you can imagine how easy this is and how nice this is for helping you with your application development. Anyway, so let's go back to the infra. So we've got our Cassandra service here. We've got our basically our Cassandra service. What I want to do is I want to ask it now, how would I connect to this with a Java application? This is where it gets a little hairy because when you're looking at Copilot and other things, it actually does. Okay, so by the way, just a little bit of trivia. Cassandra is actually written in Java, for those of you who might not know. And there's various reasons for that, but you can check that out as well. So to connect to a Cassandra database from a Java application, you can use the DataStax Java driver for Apache Cassandra. Okay. There's a basic example of how you can establish a connection. All right. Are there any other ways? Okay. Spring data, using Spring data, and it tells you how to set up the properties and the contact points as well. And then let's say, show me an application, please. What's that? Let's say, please. Let's be polite to the AI because, someday we'll all be working for it. So please create hello world. Please create hello world code that connects to this Cassandra service using Spring data. All right. Yeah, that's still not. Okay. Oh, okay. It does. All right. Great. Okay. So now, theoretically, we could look at this. So it actually generates the whole thing. Okay, this is better than the last time I tried this. Like I say, AI can be very capricious, so it's kind of interesting how things work. But I've got basically nothing up my sleeve here. We're building this out completely from scratch, and there we go. So this is the Hello World class. Okay. Okay, and then let's go Cassandra config class. We can set this up. We'll just create new Cassandra config. Okay. Save as. I don't know if this is going to work the first time, but it's not. Hold on. Let me just check something here. No. Okay. Got to get. Okay. Save that. All right. So I'm going to go through the step by step. Actually, I'm not going through exact steps. But then we're going to go to the that's Cassandra config. And then we're going to have the hello world. Oh, let's just start from the top again. So that's the POM. All right. See, this is where things are kind of incomplete. So this is not a full POM. Okay, so we'll have to do that. But this is the Cassandra config. And this is a hello world. Okay, we already got this. Wow. Save as. Java. Okay. And we need to set up the properties file. Where's that? Okay. Wait, what's this? Yeah, we got that. Where's the properties? Okay. Anyway, let's do this. I didn't really do everything together. So this is where experience comes in, because you need to be able to build this from the pieces it gives you. Basically, it's basically taking this box of options here and dumped it on my desk, and now I got to figure out what to do with it. Okay, so we do need to have the application properties file. That's going to have to be there as well. This is not a complete application, by the way. So it doesn't have the formats and the structure that you would have in a complete application. And this is a good example of AI and the limitations thereof. So that's important to know as well. But anyway, I think that gives you an idea. Basically, you have to set up the properties, and you have to set up a complete pom.xml. This is only a segment of the pom.xml that you need. And this is, and it didn't include the properties this time. It did the last time I asked. So there's a number of things that you need to know how to work with. And you need to know what a Spring Boot application looks like. You need to know what a Spring Data application looks like, and be able to put all the pieces basically together that it gives you. But I think that's a good example of the kinds of things we have. So what I'll do now is I'm actually going to go into Visual Studio Code, and I will commit this. And if anyone wants to play around with this, it'll be there and you can use it. I'm going to generate something a little bit later that is completely working using the, go to start.spring.io, generate the code, and then plug this code into it. And basically that's what you'd have to do. But we're a little bit out of time. I know we have some time for questions here, and I want to make sure we could cover that as well. Let me just say Java and YAML code. All right. Commit. And it's gonna ask me if I wanted to stage my stuff, and I do. I'm going to sync the changes. All right, so everything should be out there now on the GitHub page that's posted. It's well, it will be there in a second anyway. And that's this one here, BBen's CFE Dev Haunted DevOps. You can find that at github.com/bben/CFE Dev Haunted DevOps with dashes. And I guess that's about it. We've got 10 minutes for questions. And yeah, what'd you think?
That was awesome, Brian. I love how demo heavy your presentations are, just because we get to see what real life really looks like. And
absolutely. Yeah.
This is definitely something I needed. I don't know if anyone else in the audience feels the same way, but like a lot of times I dive into things like this and I don't know where to start. I don't know what to do. Just kind of poke at it, see what happens. So this is a really good example of just how to, start playing around with AI while coding. If you have any questions in the audience, feel free to ask. I will definitely present them to Brian. In the meantime, I have some of my own for sure. Absolutely appreciate that you call out AI for being imperfect. It feels like it's like a mash between Googling the internet and skimming through Stack Overflow, right? Like you still need to know what you're doing.
Yes. Yeah. Yeah.
But what would you say, improvement, like being able to use the chat in this way? What would you say is an improvement over what I just described, just Googling or skimming?
Just being able to, sorry, go ahead. Yeah.
No, I was done.
I jumped in too soon, but just being able to, figure out what the code does. So one thing I didn't show, I'll show real quick here. So I can do things like I can click on Cassandra service and I can go to the chat and say /explain. And it'll actually explain what this code does for those of, for folks who might not know. So the provided code is a Kubernetes service, configuration written in YAML. It knows it's a service and not a deployment. And it describes in detail everything about what this does. And then you can do something like simplify. So this is where it's a little bit better than ChatGPT. I don't know if it's going to be able to simplify this. It's already quite minimal and straightforward. Okay, so, it did. It made it even shorter. Oh, you can use a Helm chart. So it actually recommends that you use a Helm chart as well. And that's interesting. So that's not shorter or simpler, but so it's a great example of, the way things are.
That's cool.
Go ahead, sorry.
I could see an advantage for if you're new on a project, you've brought down all this source code and you just need, quick explanation of how things are working.
Yes. And actually, I was joking about it, but fix is really useful too. Because sometimes you just have a misspelled variable or something, you /fix, and it'll look at the code and it'll tell you, this variable, you can't find it anywhere else in your open files. So, it'll tell you things like that. And it'll even sometimes put a little Git style replace there for you as well. So.
Have you had a situation yet where you think you know what code does and you ask it to explain it to you and it's not what you thought at all?
Yeah, actually. Yeah. It's very good at explaining. I mean, it catches things that you might not, the scary thing about AI, it works 24 hours a day. It just knows so much more. It's seen so much more code than even the most experienced developer in the world.
Yeah.
And and it could just figure things out that you might not have caught, things you missed about what the code does or where a problem might be and things like that. And it works with pretty much every programming language. It's pretty amazing. So I showed you Pulumi, Terraform, anything. You want to convert this to another cloud providers, CLI, you can do that as well. It'll take the code and go, yeah, sure, here you go. And and the things like that take hours, and it takes seconds with this. So it's like having a really, really experienced sort of pair programmer.
Yeah, that's what I was just thinking. I'm like, we, suffer from a lack of pairs, so to speak. I see this being really valuable on that front for sure. You were using VS Code for this. Can we use any other IDE? I know I have my favorites.
Yeah, no. There's several things you can use. You can use, if you're a Java developer, IntelliJ IDEA as well. And there are others as well. Let's ask. Hey, what IDEs does code? And this is interesting because we're used to I've heard some things about. No. What about other IDEs? So it's just basically told me it runs in Visual Studio Code. I know that, but yeah.
Well, official support.
Oh boy! See, so this is where AI fails you. So there are some other IDEs you can use. Just a sec. What are they? GitHub. I know there's more. I just can't remember what they are right now. I know IntelliJ IDEA has an extension, and there's a couple others as well. One that's popular with Node. Boy, I wasn't ready for this. So Vim and NeoVim, Visual Studio Code, JetBrains, and something called Azure Data Studio. Those are where you can run Copilot at the moment. But there might be other platforms coming soon. But basically, this is where you can get it. You can also use, I know we're running out of time. I did want to show you this one thing you can do as well. If I go into my GitHub repo. So this is the repo. You can also, instead of cloning, we have this thing called code spaces. I can create a code space of this repo. And basically what this does is it creates a clone of the repo in a container that's running in a browser, and it has extensions for Copilot and Copilot chat. So you can actually run this here as well. So if you don't have access to an IDE, or you're on, I know a lot of like government agencies and stuff really lock down their machines and they might not have Copilot or any of the other IDEs that can run Copilot. What you can do here, so this is basically a cloned repo. I can go to extensions and I can say Copilot. And I can install Copilot. Where's Copilot chat? I think it's part of just Copilot now. Oh, there it is. Okay, so it's automatically installed. So Copilot chat. Let me zoom in on this for the folks out there. So Copilot and Copilot chat, I just installed it here. So now I can go back to my code up here, and I can do this again. I can go to chat, and I can say /explain. And so it works on the browser as well. So that's kind of cool. It's all there, fully functional. And you have most of the things that you have in Visual Studio Code itself, but in a code space. Then if I want to, I can change any of this and I commit it back to the repo again. Now remember, because it's in a browser, it's not the actual code you're working with in GitHub. It's a clone, and it will clone it back. And when I close this, it will actually know that I have, let's hope. So it knows that there's a code space out there already, and then I can come back and just pick up where I left off. I can also open up this code space in IntelliJ IDEA and also in Visual Studio Code, of course, and all the other formats that Copilot works in. So
that's pretty cool. I haven't played with code spaces at all yet, so that was cool. I'm glad that you showed that for sure.
Yeah, it's a big deal. It's really something that really helps with productivity, and you can preset your environments as well.
Okay.
So you can preset the environment um, for the different uh, things that you want. Like maybe you want the Copilot to be installed, ready to go, or you want some Java capabilities built in, or Red Hat, or all kinds of things. You can actually predefine your environment in code spaces when you build it.
Wow.
So, yeah.
Very cool. Very cool. Well, I think I'm left mostly impressed with just how well, it generated the YAML files and stuff. That's pretty cool.
Yeah.
Other than it telling you the truth 100% of the time.
Yeah.
Is there something specific that you wish it did that you haven't found yet?
It's a good question. Yeah, there are a few things. It would be nice if there was more context, and if it was more consistent. That would be nice as well. The consistency is an issue. I mean, I tried, you saw there was a couple of the parts that just didn't work right.
Right.
That should have worked, and just didn't go the way expected.
Yeah. I've heard that before, that you'll ask it something once and then it might give you a different answer.
Yeah.
It's like a human being. It's a little bit scary.
Yeah. It'd be nice if it would ask you clarifying answers. Like, do you want the same answer that, we gave you last time, or do you want a new answer or something?
Right.
Right. So it would be a little more interactive, but I guess that's one feature. Yeah.
Well, thank you, Brian. This has given me a lot to chew on for sure. I'm going to go check out your GitHub repo, see how much I can mess with it as well.
Yeah.
See what kind of answers I get when I ask, see how biased it is.
Yeah, well, have fun.
Interesting stuff. All right. Thank you for joining us today. If anyone has any questions, feel free, reach out to us, reach out to Brian, get these questions answered, play with the stuff on his GitHub repo. He puts a lot of work and energy and time into those. I know he has several examples out there too for other things. So hope to run into you again at some point in the future. And we have 3 minutes until our next and final talk from Brian Benz, software architect at SAS. He'll be talking to us about security and automation, other processes, with his session on supply chain robots, electric sheep, and salsa from Brett Smith. Thank you. Hi, all. We're back. Extra short break there. I got a little carried away talking about AI goodness with our last presentation by Brian Benz. Next, we have up Brett Smith. He's going to talk to us a little bit more about security and what we need to start paying attention to, maybe some strategies, things that we can do to improve our environments and our infrastructure, the way we have everything set up. So Brett, I don't want to steal any of your time because I know you have a lot to share with us. Good to see you. Take it away.
It's good to see you again. It's good to see you again. Hope you get everybody hear me all right. Pretty well.
Sounds great.
All right. So I am a principal software developer at SAS Institute. And I might be responsible for some of the supply chain pipelines that we built, but I have been using plausible deniability to escape that type of blame. Currently, I'm a security lead for R&D. For a little background, SAS is a 40-year-old analytics, artificial intelligence, and data management company. We're an ISV. We still deliver software to customers. We deliver RPMs, Debians, OCI containers on several architectures. We've got a pipeline that builds, tests, stores, and eventually allows us to deliver all this stuff to the customers. So we're a little different. I would love to go work at a software as a service in my next life, but for now, I've got lots of packages to worry about. So I'm going to talk about supply chain, robots, electric sheep, and salsa. Originally, this talk was pretty salsa heavy. Version 0.1 of salsa was really strict and really complete. And salsa for version 1.0, they have backed off and focused on the build section. So what I'm going to do is I'm going to talk about the executive order 14028 and the SSDF standards. And then we're going to throw some ISO in here and some salsa, but we're not going to talk about that really long because you guys can go read about that. And what you really want to do is you want to get to some of the crazy ideas I have. A couple of things you need to know about the executive order, like some points that they definitely lean on is that they want you to separate and protect each environment. They want you to secure hardened endpoints, improved executable security. So use compilers that do the right thing. They want least privileged access to the code and tools, provenance data and SBOMs, and they want software release integrity. So how does salsa fit in? Salsa is a checklist of standards and controls that we use to prevent tampering, improve integrity, secure packages, and infrastructure in your projects and enterprises. It's how we get from safe enough to being as resilient as possible at any link in the chain. The framework establishes 3 trust boundaries, the right standards, attestation, and technical controls, so we can harden the systems from threats and risks. This is a cool slide. It pretty much does what you said. It does what it says. One thing I want to bring up is that I'll focus a little bit later on validating artifact integrity. And that's like a key component of salsa, especially in the build section now. And so we'll get to that. Let's see. So each level works to achieve a greater sense of security based on the previous level, right? So maybe some of us are at 0.1 and, that's good luck. It's the wild, wild west, right? We don't know what's going on. In level 2, provenance exists. And there's provenance showing how the package was built. And there's documentation that helps us not make mistakes while we're building these packages. At level 2, we've got signed provenance generated by the hosted build platform. And then this prevents tampering after the build, right? So I build my package, I sign it, and then I can validate that that package is what it says it is based on the signature. For level 3, we've hardened the build platform. No devs are allowed in there. Nobody's allowed in there. There's one door in, one door out. And this helps prevent tampering during the build. And then, of course, we've built on the other layers, right? So we end up with hermetic builds, which is where we all want to be. So I have some ideas around some of these things that we want to achieve, and I'm going to go about it in a interesting way. I think you guys will appreciate it. The real answer here is that you pay for a supply chain platform and let somebody else worry about this, and you sleep at night. But some of us aren't that lucky. Some of us have a long in the tooth, organic, hybrid cloud solution of in-house solutions cobbled together with duct tape and baling wire. So, and the older that pipeline gets, the more fun it is to work on. So I'm going to present a series of what ifs, right? Let's start with something that should be obvious, but not everybody takes it as seriously as I do. And that is, what if we use GitOps for everything? Okay. I'm talking documentation. I'm talking your code. I'm talking infrastructure as code. I'm talking your policy, your ADRs. All of it is in Git. And I know you're going, well, that's kind of crazy. Why are you putting all that in Git? Well, so take documentation. Say I want to require 2 reviews on a pull request to in order for it to be merged into main. Well, then I'm guaranteed that I've had 2 reviewers of the documentation change, and I know who the 2 reviewers were by the Git history, and I know who the original author was because of the Git history, and they can't get it in until we go through through our CI, right? And so now I've got CI running against my documentation. I've got 2 reviewers, and I've got a Git blame trail to tell me who did the change and why we made the change. And then at the end, after it's merged, I run even more CI that does the publication from Git to wherever we want the documentation to end up in. For us, it's Confluence. And so we wrote a tool in Python that does markdown to Confluence. The infrastructure as code, that's pretty much straightforward. You guys all know that answer. You've got Argo CD hooked up to a repo, and then you get the same 2 reviewers that I have before you can make changes that are automated in deployments. Policy and ADR, those are 2 things where that Git log trail, that audit trail really helps you out in the long run. So those are the reasons why we use GitOps. Moving on, this is the best part. So what if we had a complete inventory of our CI/CD infrastructure? That would be awesome, wouldn't it? Seems pretty necessary. In our world, the DevOps teams get to do their own deployments. Seems safe, right? Compliance and security problem 101. I didn't deploy it, so I don't know where it is. So how can I enforce it? Well, we've got the old school way. I've got hundreds of Jenkins servers. I got a Confluence page over here that's got a list of all the URLs of the Jenkins servers. And so we know where all the Jenkins servers are based on this list, except for the ones that the developers deployed with Shadow IT to get around the restrictions we put on the Jenkins servers we have. Okay, so that didn't help that much. So the next problem we ran into is that we built an event-driven framework for our pipeline. Its services and our events are all asynchronous. And we're not sure what service gets triggered by what event because the development teams can deploy their own services on top of the infrastructure we've deployed. So how do we fix this? What are some ideas I can give you guys around this sprawl that I have caused? And, it was my fault, that's what happens. You're doing stuff, you break things, you lose things. I don't know where that server is. Anyway, we built what if we build out a framework so the DevOps teams get inventory management for free? What if we automate the IAC audits, which would tell us where things are deployed? That's not too bad an idea. I mean, as long as they checked it into a Git repo, based on my GitOps theory, then we would know that the manifests would tell us where these things are. That doesn't help if they didn't use GitOps. So what if we had event-driven registration? Basically self-registering services. The idea would be is that I've got this service. It's running on the events in the event framework, and then there's a Kafka topic, and the service ARPs itself when it starts up and says, hey, I'm here. It goes on the Kafka bus. You've got a service over here that's collecting up all these ARPs off of the Kafka bus and cataloging where all the things are. That's that's a pretty decent idea, right? That's great, right? Until you find out that you're 2 abstraction layers up and the IP addresses you have in the Kubernetes cluster are only related to the Kubernetes cluster. All right, so now I've put myself in that situation. How do I solve that? What we could do is there's this thing called downward API, right? And then for Kubernetes, this means exposing the pod information to the containers through environment variables, right? So in the manifest, there's a couple of environment variables, and they surface up lower level Kubernetes information. It tells us which cluster it's running on, where that cluster might be. And then we get farther down the chain. And I know what you're thinking. You're like, well, if the developers are doing the deployments, how do you get them to add in this downward API? Well, the trick is that you put it in the example manifest and you don't mark it as something that they need to change. And I guarantee you the developers will deliver it or deploy it just as it is, and you'll get your downward API. So yeah, it is what it is. All right. So the next thought I had is that what if we remove out of band human checks, right? Every time I come around as a security lead and implement a bunch of security, developers get bogged down. It makes them harder to get their job done, and we made their job more complex. So what if we shift everything as far left as we can, right? And then automate everything else to the right. And this keeps the dev experience where I want it, which is git, pull, hack, git, push, create, review, right? Get 2 people to review it, and the PR passes all the CI checks and it merges. The CI checks, of course, are over on the right, or kind of hang on. The CI checks are right here in the quality and the scan, and right in before the source code gets merged. But so if we get to that point, the devs don't care what happens after they've fixed everything in the pull request. And then we have, how do you handle vulnerabilities in that case? So, we had some vulnerabilities, we fixed them. So we're running Sneak, plug for Sneak. We're running Sneak, and we have IDE plugins so the developers can see all of their stuff in their IDE. We also have integration into the GitHub pull requests. And so the GitHub pull requests won't pass until we've remediated whatever issues we've run into. So the developers go and they fix all these things, and then they, remediate, and then there's a time box on the remediation, and then the automation on the right swings back around every time and says, okay, your time frame to fix this remediation is up. You either need to get another exception or I'm going to break the build. I need a clicker. Wait, go back. Click too far. So as we shift left, we get the problems earlier in the STL lifecycle. Scanning and code quality are remediated in the IDE. Code merge is blocked until the quality and security standards are met. Keeps your dev in the IDEs. They're not off in the web browser, back in the IDE. Brian's talk before this made me think about that, how he could get so much done and never leave his IDE. And then after the merge, the robots are the ones doing the due diligence and producing your audit trail. It keeps the developers working on the code, and it keeps the robots keep the compliance and security as best they can. And then we automate provenance on the right side in the pipeline, so it can't be falsified or tampered with. Okay, all this shift left, this compliance is great, but we still have attack vectors. If this doesn't keep you up at night, it should. And compliance doesn't equal security. So just because we're compliant doesn't mean we don't have these attack vectors. It just means that we have compliance. Compliance can help, but closing the attack vectors should be priority number 1. Monitoring. Monitoring is great. We should do that. However, verification of environment, materials, process, and artifacts before running the actions increases security. And look, I'm not telling you not to monitor. Monitoring auditing is a big part of the EO 14028 focus, but closing attack vectors should be priority number one. Okay. Attestations. You've been hearing me talk about provenance. Provenance and attestations, we kind of interchange them a little bit. It's the same. It's kind of all along the same idea, right? So what if we make SBOMs? SBOMs are good. We should do that. In the end, SBOM is just a list of ingredients. At some point in the supply chain, we must be able to vouch for ourselves, right? So we have to create an attestation. The way to create an attestation that is non-falsifiable is to cryptographically sign it to verify your assets. And then we automate the provenance so that it can't be falsified again. Let me give you an example of what an attestation would look like. This is a real world example, not a YAML example. So you're going to get lab work done with your doctor, right? And then you've got the environment. And the environment is what lab is the test taking place in and on what date. The process is what machine is performing the test and what are the configuration details of that test. The materials are whose blood is going into the test. This is very important. Is the chain of custody verified? And the artifact is the output of the test the output of the test is the test results. The blood test results should be verifiable and traceable. So what if we teach the robots to verify the environment, the materials, the process, and the artifacts before running the actions? By verifying everything, we've already said we're going to increase security. And verification tools validate the signed provenance and verify metadata, including verifications of the source repository used to build the binary. That is a lot of verification. But verification allows us to answer an important question. Is that an electric sheep or is it a wolf? Rachel was replicant. How did Deckard miss that? All right. So in the end, we want to build some automation to tend to our electric sheep. And then what does that look like? So the robot gets the signed provenance and validates the signature of the provenance. And then he uses the SHA sums from the provenance to validate what it's about to execute. Like if the rules for this particular build are make install, then I want to make sure that I'm running make and make install and not make install, make foo, right? And then it uses the same, a different piece of provenance to validate that the tools are what they say they are, right? If I'm using version 1.0.0 of tool foo, I want to make sure that I didn't get 2.0.0 of tool foo. It validates that the instructions are what they're supposed to be. So depending on what type of build scripts you're using, it goes through and says, okay, you're going to run this step, and this step. And then we SHA all that and it gets put in the provenance. And then when you go to run it, you pull the provenance and go, okay, I'm running this step, this step, this step. Is that what we're doing here? And then in the end, it validates the resulting artifact, and it creates signed provenance for it. So now you've got this artifact that you've got signed provenance for, so that when you go and download that artifact to go use it somewhere else, you can grab its signature and go and know that it's what it's supposed to be and it was built in a process that you trust. So the next trick is that you use the pipeline to build the pipeline. So in the past, we might have been very worried about the product we were delivering to the customer and not as worried about the pipeline that builds the product that delivers to the customer. But now we're very worried about that. So you use the supply chain to secure the supply chain, and none of your infrastructure should be built anywhere other than this one pipeline. Now, there's another thing I want to get into, but it's probably a presentation for another time, and that's deterministic builds using two different pipelines. The idea is that I've got pipeline A and pipeline B, and they are different mechanisms, and we build the same source code through them. And at the end, we test the binaries, and if they're identical, then we are fine, and nobody's tampered with anything. Let's see. So zero trust, it's coming. And securing your supply chain is not just scanning the code in compliance, it is implementing zero trust. And you want to follow the principle of never trust, always verify. And the verification steps we talked about are also required for zero trust. I got to do that really fast. Melissa, you want to pop back in? Because I'm Smitty and I'm afraid of robots.
I was going to ask you about that.
We're getting to it, right?
Yeah. And I think we might as well just jump into that because I think you have a good story about this. Yeah. So why are you afraid of robots, Brett?
You run amok. Do you know how easy it is to get a robot to run amok? So we're building out this event-driven pipeline, right? And it's early, and we've got the R section, the infrastructure of it kind of figured out and built out. And the idea is that you post a receipt to the service, and then the service creates an event, and then everything downstream is listening to that event. It uses the data that you posted for the receipt to go do stuff. So we had an early adopter, and we told them that they were going to build this thing to watch for these events, and then it should do something, and then post receipts, so that it could, on what it did, right? And this particular thing was a security thing. Well, we were early and we didn't think about guardrails. So this thing managed to fork bomb itself into a 97 megabyte receipt. So it was posting a receipt. The service was creating an event, and it was listening for the same event and firing itself again.
Oh,
right.
No.
And then the original message was like, a couple hundred kilobyte, and it made it to 97 megabyte before it kicked over and died. This led to us putting in a 1 megabyte limit because Kafka at the time had a 1 megabyte limit. So we put a 1 megabyte limit on the service, and we went and wrote a bunch of code into our base library that made sure that you weren't allowed to listen to the event you were creating. So that one was pretty awesome. Yeah, and it happened more than once, which that's how it goes.
Yeah.
Security.
So easy.
Go ahead.
So easy for
it
to happen.
We were doing something that didn't have a lot of. This was 4 years ago, so there wasn't you couldn't Google on the internet about what we were up to.
Right.
Kafka was mainly a streaming service, and we were kind of cheating and using it as a message bus. So it was interesting.
Yeah.
What was the other story I'm supposed to tell you?
That was the main one.
Right.
Yeah. But I did have a couple of other questions for you, though. Why all this push for GitOps?
Why all the push for GitOps? Oh,
yes.
That wasn't the main one. Why all the push for GitOps? Because here's an example. In a previous team, and they did all of their ADRs, right? We know what ADRs are, right? They're architectural decision records. And these are like a point in time. I said, Melissa, you and I are going to put together this event-driven system, and it's going to look like this. And so you're like, well, we need to make sure we talk to the Kafka bus this way. And we're going to go, okay, I'm with you, right? The messages have to look this way. We go write an ADR, and me, you, and everyone else in agreement is on the top of the ADR. And then we commit it to the Git repo. Well, in my case, I commit the Git repo, but we say, okay, this is the ADR. So on October 31st, we made this horribly stupid decision. Next year, we come around and we're like, my God, who made that decision, right? And then it's like, we go back to the ADR and we'll go, oh, it was Melissa and Brett. Well, figures, right?
Of course.
They don't make good decisions anyway. So if you check that into Git, so anyway, we put that in Confluence, okay? we forget to lock it down. Anyone could come along and hack it, right? Change it. We could accidentally delete a section of it and push update right afterwards. And yes, Confluence has a fallback and all that other stuff. But 2 weeks from now, our powers that be are going to swing in and say, we're not paying for Confluence anymore. You're going back to Wikipedia.
Right.
And so now you've got this document only in Confluence, in a Confluence markdown, right, that you've got to go convert over to Saspedia. Now, say you got hundreds of those documents or thousands like I do, right? If they're in Git, I've got the blame trail, and all I have to do is write something to translate them from whatever language I decided to write them in. And look, I'm old school. I know a lot about old style doc stuff. We can talk latex if we want to, but we did Markdown because it renders really well in GitHub, right? And so now you've got a renderer for your Git, your documentation. You've got an approval system. You've got a Git history of what's been changed in your documentation and when. And if I wanted to move from GitHub to GitLab, it's easy, right? And so that's pretty much the reasoning behind the documentation. I mean, the IAC explains itself. Infrastructure and code. What day did I deploy this, and what day did the manifest change, and who's the knucklehead who put this Docker container in that manifest? Get blame, Smitty. I did it. I didn't. The robots did it. This goes back to why I'm afraid of robots. See, I didn't make that change to the manifest. We built a new image. The event system caught that build receipt, went and updated the manifest, updated it, pushed it, Argo CD caught it and deployed it. I knew I was supposed to put tests in there before I did that.
Right.
So the idea here is that you can hurt yourself with GitOps if you let the robots do the work, because when you do Git blame, it's like robot 1, robot 2, robot 3. You need unique identifiers for the robots, and you need to be careful with mixing Git. How do I always put it? I don't like repos run by humans. I don't like robots checking in stuff to repos run by humans. You keep the robot repo and the human repo separate. And then so I could go back to the human repo and go, oh, this is why we changed how the part of this part of the deployment. And then the other one is, oh, well, this robot went and just deployed that because we built it. We just need to go build it again and fix whatever was broken, and it goes out again. It's a real CI/CD, right? It's like, oh, well, just go build it again, and then or fix the bug and build it again. But Git ties back into all that, right? Because it's your audit trail and it's your free audit trail. Mm-hmm. So that's pretty much why everything should be GitOps.
You have a lot of experience. One thing I appreciate about you, getting to know you, is just you've had a lot of trial and error. You've had a lot of quite a journey, getting all of this stuff in order, making it more secure, making sure, your ops is getting along with your devs too. And that was one thing I wanted to touch on. But before we get to that, I do want to ask you about Salsa, because you brought up Salsa at the beginning of your talk, and you were talking about the different versions. And we've had discussions about this, and I just want to know your feelings. I think this is a good venue for it. There were changes between 0.1 and 1.0. Tell us what changed and how you feel about it.
So when the Salsa spec came out, I'm going to tell you, I got AI camera that follows my head. It's pretty cool. So when I wobble, we're talking, it follows me. Anyway, so when the Salsa spec dropped, I was like, oh, this is the answer. Because version 1.1 covered almost everything that the EO, the executive order, covered. And it was like a guidelines for it, right? You had the source section, you had the build section, you had the provenance section. I mean, it had all the sections. And it took care of everything you needed to do. And if you got to Salsa level 4, you were pretty sure you had done everything you could do to lock down your pipeline. I'm not going to lie, it was daunting. I looked at it and I was like, well, where are we and I could squint and get us to salsa level 1. And then there was 4 levels at that time. And I was like, okay, we're going to shoot for salsa level 4. We're going to go put a plan together, and we're going to lock down everything. We're going to have, hermetic builds, sign provenance. We're going to have the source code's going to be locked down. We're going to have 2-person reviews on every piece of code. We're going to make sure that the owner of the code also does a review of any pull request. He could be one of the 2, or she could be one of the 2, or they could be one of the 2. Somebody's one of the 2. As long as it's not a robot. You don't want robots checking your code, because we saw what happened to Brian, right? I mean,
Right.
Just saying. It was a beautiful thing, and I went and wrote up all this stuff on it, made these presentations. We started working on it, and I think what happened, and so Google was the original drop the spec. And I've talked to some people from Google that know, and they're like, yeah, no, our internal rules make salsa look trivial. I mean, they're way, way more strict about everything. And I think what happened is as the community started to take over and Google started to draw back a little bit, the community's like, we'll never get this done.
Right.
And so they took the part that's probably I'm torn between the source code and the build section, but I think the build section is the most important section of the salsa doc. A lot of the rest of it is sysadmin 101. And they focused in on that, and they dropped the source piece and they dropped the other pieces. So it's pretty much just the build environment. And then they dropped down the levels to only having 3 levels. I still think level 3 is close to what we were calling for level 4, but they still dropped back on some of the requirements. And I don't know exactly. I really need to go track somebody down that's in that, in that space and ask them what they think happened. But yeah, that's how I think it went. But so that's why my talk ended up, I had to go pull from ISO 27001 for source code rules, right?
Right.
In ISO 27001, there's in the 27002 guidelines, they go through and tell you what you should do to lock down your source code on a least privileged, basis, need to know, and walk through that. And it lined up pretty well with the salsa spec as best it could. So I had to improvise there. So hopefully they get back to it. I mean, it says to be TBD on all those things. So I'm assuming the community will come back and improve on it and get back to it. You and I should go figure out how we can go contribute to it, because that's
I think getting more input from the community is also helpful for sure, and especially from someone like you who's been in the middle of it and trying to implement all of these things. And I know that's an overwhelming process starting from zero. So just having, something like some goals that are outlined to get to is good. And I'm very sad that us as human beings, we have to feel pain before we make changes. And unfortunately, it feels like in a lot of cases, there's a lot of security measures that most of us are deficient in, that we are only now looking at and trying to improve.
So when I was at All Things Open, you were there. I saw a talk on AI to learn Python, and it was a wonderful talk. And the thing that the presenter mentioned the most is that you need to feel some of the struggle, right? So that the accomplishment feels good. So it shouldn't be so easy, but I would sleep better at night if it was just easy. I mean,
can you pinpoint the most difficult part for you and everything that you've done so far? What was the most difficult piece? And something I was alluding to earlier, did you have any problems with getting folks on board with this, with the changes that you wanted to make?
How long you been in this industry?
I think I already know the answer.
Yeah. You remember all those attack vectors I showed on that slide? Yeah. those are multiplied when you have developers. And so my famous saying is, if you have developers, you have attack vectors. It's hard. This is why we work so hard on the shift left, right? And this is why, so like if you take how Brian was working, where he just never had to leave the IDE and he could stay focused. The problem is it's not like that when you first start out. And the developers are already trying to get feature A and feature B out. And then you can run and tell them that the piece you released 2 months ago has 5 CVEs, go update it. And as they start to update it, it breaks the code and they have to go mess with the code, right? And then so they lose time to this CVE on something they thought was already done. That makes them not want to do this. So fixing this stuff, so that's been the hard part, is getting developers on board with them understanding that security is their problem as well as mine, right? And then I should not use the word problem. Security is everyone's responsibility as a company, because like I like revenue. I know you like revenue. I like my bonus, right? And so if the more secure we are, the better chance we have of getting our bonuses, because it's just that one thing that's going to get us, nicked up, and it's bad for the company. It's bad for the reputation, and it could be bad, really bad for the customer. And my customers are government agencies and banks, so we don't really want that to happen with our customers. Anyway, so getting that message across has taken a lot of work. But making it easier to adopt makes it easier to get it going, right? We automated a lot of our security checks. On the right side, we will run the scan automatically after the build, and then we will create JIRA issues automatically if we have things that need to be addressed. And then we sort out things like the base image. If the base image has vulnerabilities in it, we create JIRA issues, and they get assigned to the guy who owns the person who owns the base image, not all the developers. And so that was pretty interesting, because we didn't do that at first, and we made a mess. And not being careful with who we assigned things to was really, really heavy. We're on the better side of that.
Yeah.
Now. The torch mobs are down. The pitchforks have been pushed down. So, we're better from that.
You're all on the same team again, all trying to do the right thing.
No, but they're not trying to chase us down the hill anymore or burn the castle. So, yeah. We're all developers.
Yes. Well, thank you so much for joining us. Thank you for your perspective, sharing your experience, giving us a little bit of a reality check on what it takes to secure a pipeline. I think that's something that all of us, developers, operations, everyone involved in getting this software out, need to know about.
Thank you.
Thank you. All right, everyone, that is it for our Haunted DevOps. We covered a number of different topics. We learned about disaster recovery. We learned a little bit about testing. We learned about observability and using distributed tracing, deploying and using AI to do it. And then, a lot about security at the end there. I hope you found this valuable. Hope to run into these speakers again. They're all great presenters, have a lot of information to share. And it was a privilege being a part of this. Thank you all.